कुलपति हैं, और वेलकम स्पीच के लिए हमारे प्रोफेसर डॉक्टर BN ओझा सर, जो प्रेसिडेंट है हमारे दर्शन परिषद के बिहार के, उनका वेलकम स्पीच होगा। उसके बाद जो है हमारे जो आज के मुख्य रिसोर्स पर्सन हैं प्रोफेसर डॉक्टर काशीनाथ धुरके सर, जो NIT वारंगल से हैं। उसके बाद डॉक्टर प्रकाश सिंह झा सर, डीन ऑफ स्कूल ऑफ अप्लाइड मटेरियल साइंस, जो सेंट्रल यूनिवर्सिटी गुजरात से हैं। उसके बाद नेक्स्ट हमारे स्पीकर हैं डॉक्टर BD त्रिपाठी सर, जो विभागाध्यक्ष हैं MK कॉलेज दरभंगा में। उसके बाद जो नेक्स्ट हमारे रिसोर्स पर्सन है प्रोफेसर डोसेंट अरुल मुरुगन सर, KTH रॉयल इंस्टीट्यूट ऑफ टेक्नोलॉजी स्टॉकहोल्म स्वीडन। उसके बाद प्रोफेसर डॉक्टर नरेश कुमार, प्रोफेसर जो यूनिवर्सिटी डिपार्टमेंट ऑफ केमिस्ट्री BNMU मधेपुरा में प्रोफेसर हैं और प्रोफेसर इंचार्ज एजुकेशन के भी हैं, जो आज के हमारे कीनोट स्पीकर भी हैं। फिर उसके बाद जो चेयरपर्सन है डॉक्टर श्यामल किशोर, जो हम लोग के जनरल सेक्रेटरी हैं दर्शन परिषद बिहार के, और आज के कन्वेनर डॉक्टर सुधांशु शेखर सर PRO जो हैं और डिप्टी रजिस्ट्रार एकेडमिक भी हैं। तो सब लोगों का हम हार्दिक स्वागत करते हैं। अब हम वेलकम स्पीच शुरू करने के लिए प्रोफेसर डॉक्टर BN ओझा सर, जो प्रेसिडेंट हमारे दर्शन परिषद बिहार के हैं, उनसे आग्रह करते हैं, उनसे निवेदन करते हैं कि वो अपना वेलकम स्पीच शुरू करें।
धन्यवाद आनंद मोहन जी, बहुत बहुत धन्यवाद। आप लोगों ने एक इंटरनेशनल वेबिनार की व्यवस्था की है, आज शुरू कर रहे हैं, इसके लिए आपको बहुत बहुत बधाई। सर्वप्रथम मैं माननीय कुलपति प्रोफेसर ज्ञानंजय द्विवेदी जी को इस वेबिनार में उपस्थित होने पर हार्दिक स्वागत एवं बधाई देता हूं, आभारी भी हूं, जिन्होंने अपने संरक्षण में दर्शन परिषद बिहार एवं ठाकुर प्रसाद महाविद्यालय BN मंडल विश्वविद्यालय मधेपुरा के संयुक्त तत्वाधान में सस्टेनेबल केमिस्ट्री फॉर द फ्यूचर पर महत्वपूर्ण वेबिनार करा रहे हैं, जो आज वैश्विक समस्या को सुलझाने में महत्वपूर्ण भूमिका अदा कर सकता है। ठाकुर प्रसाद महाविद्यालय के कर्मठ विद्वान प्रधानाचार्य डॉक्टर KP यादव एवं उनके कॉलेज परिवार को बहुत बहुत धन्यवाद, सभी धन्यवाद के पात्र हैं। मैं उनका भी मंच पर स्वागत करता हूं, आभार प्रकट करता हूं, जबकि वो हैं, लेकिन फिर भी एक कर्तव्य के रूप में मैं उनका हार्दिक अभिनंदन करता हूं। सम्मानित मंच और सम्मानित मंच पर विद्वानों की बहुत श्रृंखला है, कुछ नेशनल है, कुछ इंटरनेशनल है। ऐसे विद्वानों के बीच हम आज उनकी बात को सुनेंगे। उसमें सबसे पहले विद्वान चिंतक डॉक्टर काशीनाथ धुरके जी हैं, जो NIT वारंगल के एसोसिएट प्रोफेसर डिपार्टमेंट ऑफ केमिस्ट्री हैं। डॉक्टर धुरके जी दर्शन परिषद बिहार एवं ठाकुर प्रसाद महाविद्यालय मधेपुरा के सभी सदस्यों की तरफ से हम आपका स्वागत करते हैं, अभिनंदन करते हैं और हार्दिक बधाई और शुभकामना देते हैं। सम्मानित मंच पर उपस्थित है डॉक्टर प्रकाश झा जी, डीन स्कूल ऑफ अप्लाइड मटेरियल साइंस, सेंट्रल यूनिवर्सिटी गुजरात के भी हम आभारी हैं, जिन्होंने अपने व्यस्तम जीवन में से कुछ पल इस वेबिनार के लिए निकाला है। आपका हार्दिक स्वागत एवं अभिनंदन। डॉक्टर BD त्रिपाठी जी, हेड ऑफ द डिपार्टमेंट ऑफ केमिस्ट्री LNMU दरभंगा, आप का एक बहुत बड़ा नाम है केमिस्ट्री में, नेशनल इंटरनेशनल फेम के आप विद्वान हैं। कार्यक्रम में उपस्थित होकर मंच को गौरव प्रदान किए हैं, हम उनके प्रति भी आभार प्रकट कर रहा हूं, हार्दिक स्वागत एवं अभिनंदन। डॉक्टर एनरुल मुरुगन, एसोसिएट प्रोफेसर KTH रॉयल इंस्टीट्यूट ऑफ टेक्नोलॉजी स्टॉकहोल्म स्वीडन से आए हैं, इस वेबिनार से जुड़कर हमें गौरव प्रदान किया है। मंच को शोभायमान कर रहे हैं, हम उनका दिल से स्वागत करते हैं, आभार प्रकट करते हैं। आप सभी केमिस्ट्री के विद्वान चिंतक हम लोगों का ज्ञान वर्धन करेंगे, ऐसी आशा और विश्वास है। प्रोफेसर डॉक्टर नरेश कुमार जी, जो यूनिवर्सिटी डिपार्टमेंट में केमिस्ट्री BNMU मधेपुरा के विद्वान चिंतक हैं, रसायन शास्त्र के हेड हैं, मंच पर हम उनका भी स्वागत एवं अभिनंदन करते हैं, शुभकामना प्रकट करते हैं। प्रोफेसर श्यामल जी हमारे दर्शन परिषद बिहार के ऐसे कर्मठ प्रधान सचिव हैं जिनके बारे में, उनके कार्यपटुता के बारे में अगर कुछ भी कहें हम, तो सचमुच में सूर्य को दीपक दिखाने की बात होगी। जब से हम लोग, अपने मुंह से ये बात नहीं कहना चाहिए, लेकिन हमारे डायरेक्शन में, हमारे देख रेख में श्यामल जी जो महामंत्री हैं, उन्होंने दर्शन परिषद में इतना काम किया है कि दर्शन परिषद भारत के मंच पर खड़ा दिख रहा है। मैं उनका स्वागत क्या करूं, वो हमारे घर के हैं, लेकिन फिर भी हम उन्हें बधाई देते हैं और हार्दिक स्वागत और अभिनंदन उनका करते हैं। डॉक्टर आनंद मोहन झा जी जो ऑर्गेनाइजिंग सेक्रेटरी हैं, हम हृदय से आपका स्वागत है, क्योंकि आपका ही ये फंक्शन है और हम लोग, आप लोग मिलकर इस इंटरनेशनल वेबिनार को कर रहे हैं। तो हम आपको स्वागत आपका क्या करें, लेकिन उज्जवल भविष्य की कामना करता हूं। आपके इतने बड़े इंटरनेशनल वेबिनार को मूर्त रूप दिया है, तथा अंत में हम अपने अनुज छोटे भाई एवं कन्वेनर डॉक्टर सुधांशु को भी बहुत बहुत बधाई देता हूं, बहुत शुभकामना देता हूं। आपके अथक कदम से इतना बड़ा कार्यक्रम सफलता की तरफ अग्रसर है। हम आपको शुभकामनाएं एवं सफलता की बधाई देते हैं। वो ये जो हमारे सुधांशु जी हैं, सुधांशु जी एक ऐसे व्यक्ति हैं जिनके बारे में बार बार कहा करता भी हूं कि इतना तन मन धन से दर्शन परिषद के प्रति कोई समर्पित हो, ये बहुत कम देखने को मिलता है। आज की पीढ़ी में तो कुछ है जिसे श्यामल जी जैसे लोग हैं, लेकिन आने वाले पीढ़ी में मुझे नहीं दिखता है कि ऐसा समर्पित कोई व्यक्तित्व तो दर्शन परिषद में है। इसलिए मैं इनको कहता हूं कि आप कम से कम बिहार दर्शन परिषद बिहार के भविष्य हैं। आगे आप ही इस दर्शन को, आप जैसे लोग ही इसको आगे बढ़ाएंगे। और अंत में पुनः मंच पर उपस्थित सभी विद्वान चिंतकों का एवं इसके जुड़े सभी विद्वानों का मैं हार्दिक स्वागत और अभिनंदन करता हूँ। विषय बहुत इंटरेस्टिंग है, सस्टेनेबल केमिस्ट्री फॉर द फ्यूचर। मैं तो इसमें बहुत कोई वक्ता नहीं हूं, लेकिन फिर भी आज अच्छा लग रहा है कि सारे विद्वान हमारे उपस्थित है केमिस्ट्री के, और उनसे कुछ विद्वतापूर्ण भाषण सुनने को मिलेगा और हम उससे लाभान्वित होंगे। लेकिन कुछ जो प्रश्न है मेरे दिमाग में, वो मैं आप लोगों के सामने रखता हूं ताकि उस पर आप लोग कर सकें। विषय बहुत ही इंटरेस्टिंग है, इस पर हम लोग विद्वान चिंतकों से पूरी बातें सुनेंगे। लेकिन जहां तक मैं समझता हूं, सतत विकास रसायन शास्त्र का एक समावेशी सिद्धांत है। तो मनुष्यों की मूल सुविधाओं को बिना प्राकृतिक संसाधनों के, आज के प्राकृतिक संसाधनों का आज के समाज को सतत विकास मार्ग पर आगे ले जाने की क्रिया है, जिसमें केमिस्ट्री का बहुत बड़ा योगदान है। प्लास्टिक हमारे समाज के लिए आज बहुत उपयोगी होने के बावजूद इसका बढ़ता हुआ चलन हमारी जिंदगी को उभर बनाते जाते हैं। कुछ दिमाग में जो मेरी बातें हैं वो केमिस्ट्री के विद्वान ही सॉल्व कर सकते हैं। बावजूद इसका बढ़ता चलन हमारी जिंदगी को दुर्भर बनाते जा रहा है। शायद अभी तक 14-15% प्लास्टिक का ही रिसाइकलिंग किया जाता है। यह विश्व के पर्यावरण के लिए एक बहुत बड़ा चैलेंज है। आप कोविड-19 के दौर में प्लास्टिक का उपयोग पीपीई किट आदि में बहुत हो रहा है। अस्पतालों के वेस्ट का डिस्पोजल कैसे किया जाए ताकि मानव की जिंदगी में पर्यावरण को सही दिशा मिले। इस तरह हम पाते हैं कि आज रसायन वैज्ञानिकों को अनेक प्रकार के चैलेंज का सामना करना पड़ रहा है, जिससे उन्हें देखना है, उनकी व्यवस्था भी करनी है। विद्वान चिंतकों का उपस्थित है, सारे विद्वान चिंतक हमारे उपस्थित हैं जो रसायन शास्त्र के विद्वान हैं। उनके विद्वतापूर्ण ज्ञान प्राप्त कर हम बहुत सारी समस्याओं का निदान कर सकते हैं। और पुनः एक बार उनकी बात सुनेंगे और पुनः एक बार हम सारे मंच पर, सम्मानित मंच पर उपस्थित विद्वान, कुलपति प्रोफेसर ज्ञानंजय द्विवेदी जी, कन्वेनर सुधांशु जी, आनंद मोहन झा जी और इससे जुड़े हुए सारे विद्वान, सारे लोग, चाहे वो शिक्षक हो, शिक्षकेतर कर्मचारी हो जो इसे इंटरेस्ट रखते हैं, उनको उनका बहुत स्वागत है और बहुत हार्दिक अभिनंदन है। जय हिंद, जय भारत, धन्यवाद। हेलो।
जी बहुत बहुत धन्यवाद सर, आपका बहुत
ही समझ से लगातार राष्ट्रीय सेमिनार की श्रृंखला, आज हम लोग अत्यंत ही महत्वपूर्ण विषय पर एक अंतर्राष्ट्रीय सेमिनार के आयोजन के लिए उपस्थित हुए हैं। यह सब हमारे दर्शन परिषद बिहार के अध्यक्ष प्रोफेसर बीएन ओझा साहब की प्रेरणा का फल है और इनका हमारे प्रति जो स्नेह है, जो आशीर्वाद है, यह हम कभी नहीं भूल सकते हैं। हम आपके आभारी हैं सर, आपने हमें सहमति दी दर्शन परिषद के तत्वावधान में इस कार्यक्रम के आयोजन के लिए और आपके स्वागत भाषण के लिए हम आपके आभारी हैं और आशा ही नहीं, हमें पूर्ण विश्वास है कि आपके नेतृत्व में दर्शन परिषद बिहार निरंतर ऊंचाइयों को प्राप्त करेगा। आप हमारे बीच
धन्यवाद। सुधांशु जी, आनंद मोहन जी, बहुत बहुत धन्यवाद आप लोगों को।
भाषण करेंगे, लेकिन द्विवेदी सर को हमारे साथ जुड़ने में कुछ कठिनाई हो रही है, इसलिए मैं आनंद मोहन जी से आग्रह करूंगा कि हमारे अगले वक्ता को आमंत्रित करें। जैसे ही द्विवेदी सर हमसे जुड़ेंगे फिर हम उनसे उद्घाटन भाषण सुनेंगे। आनंद मोहन जी कृपया कार्यक्रम को आगे बढ़ाइए।
Now, our next speaker, who is our resource person of this seminar, international webinar, Dr. Dhurke Kasinath sir. He completed his BSc in Botany, Zoology and Chemistry from Kakatiya University, Warangal in 1996 and MSc in Organic Chemistry from Osmania University in 1998. He started his research career as a project assistant at Indian Institute of Chemical Technology, Hyderabad from August 1998 to December 1999. After qualifying CSIR JRF exam, he moved to Indian Institute of Technology, Mumbai and obtained his Doctor of Philosophy degree working with Professor Somb Sivarao Kotha in 2005. After completing his PhD, he went to University of Strasbourg, France on postdoctoral fellowship and worked with late Professor Charles Mioskowski, June 2005 to October 2006 and June 2007 to March 2009. During his stay in France, he visited the country like Belgium, Germany, Switzerland, Italy and Spain. He came back to India in March 2009 and joined Bristol Myers Squibb Research Center, BBRC, Singene International Limited, Bangalore as research investigator from May 2009 to June 2011 and worked in the drug discovery program, cancer and cardiovascular areas. In 2011, he moved to School of Pharmacy, NIMS, University, Mumbai as associate professor. In April 2012, joined NIT Warangal as assistant professor and currently working as associate professor in the Department of Chemistry, NIT Warangal. Dr. Kasinath sir guided about 50 students for their dissertation. 2 students have got their PhD under his guidance and 3 students are working currently. He has published 35 research papers in national and international journals. Dr. Kasinath sir delivered more than 50 lectures at various platforms. His passion is to interact with school children and motivate them to take science as career, deliver lecture on scientific temper, motivation and career. His area on research are homogeneous, heterogeneous and organocatalysis, catalyst-free reactions using green solvent. He is one of the best and dynamic associate professor of NIT Warangal. I request Dr. Kasinath Dharuke sir to deliver his lecture. Please, sir.
धन्यवाद सर। Shri B.N. Ojha ji, President, Docent Parishad Bihar, Professor Dewvedi ji, Vice Chancellor, BNMU Madhepura, Professor K.P. Yadav sir, Principal, TP College Madhepura, all the organizers and resource persons of this seminar. Good afternoon to all of you. At the outset, I would like to congratulate TP College Madhepura and the university for conducting a seminar at international platform on sustainable chemistry for the future. I also thank Dr. Jha for giving me the opportunity to share my views and also some of the work which we are doing at NIT Warangal. I am sharing my screen. Hope it is visible. Yeah. You have chosen a topic of current needs, sir. That is sustainable chemistry for the future. We know that 2015 consortium of United Nations, including 190 plus countries, recommended the sustainable goals for 15 years to achieve. I have mentioned some of these goals here, but some of the goals mentioned here are related to today's seminar, that is good health and well-being, and clean water and sanitation, climate action, life below water, and also responsible consumption and production. So these are some of the things which are related to chemistry. That's why I thought to bring some of the sustainable development related goals recommended by UNO to the notice of the audience. Coming to today's topic, sustainable chemistry. So what is sustainable chemistry? How to define sustainable chemistry? I was looking into literature and I found this statement that meeting the needs of present without compromising the ability of future generations to meet their needs. This is the sustainable approach. What is meant by this? Meeting the needs of present. So we have to meet the needs of present without compromising the ability of future generations to meet their needs. That means whatever the technology which we use, whatever the product which we use, whatever the product which we develop, it should not create any problem to the coming generations in terms of resources, in terms of environment, in terms of climate change, in terms of cost, in terms of lifestyle. So that is what I mean to say from this statement of meeting the needs of the present without compromising the ability of future generations to meet their needs. That is the sustainable approach. Then I have an image. You can see here, I have an image on the right hand side where we do a lot of organic chemistry, we develop a lot of products, whether it is polymers or materials or drugs or any chemical produced. The current practice or olden practice used to be the use of organic solvents. Over a period of time, the use of organic solvents led to the damage of ozone layer, led to the environmental pollution, led to the environmental pollution, led to the led to the environmental pollution, led to the soil pollution, water pollution, etc. So this is where we are landed into. Okay. Then the need of the hour is conversion of this situation into the image which I gave on the left hand side. That is the green chemistry or use of greener methods, use of sustainable methods, and the environment whatever we have. You can see here the image of a tree which is dried without leaves, and we have to convert this dried.
1 minute.
Can you please mute? Can you please mute mic?
आदरणीय बीएन ओझा सर, प्रेसिडेंट दर्शन परिषद, आपसे रिक्वेस्ट है, अनुरोध है कि कृपया अपना माइक को अनम्यूट करें सर, म्यूट करें सर, प्लीज सर। बीएन ओझा सर, कृपया अपनी माइक को सर म्यूट करें सर, प्लीज सर।
आवाज स्पष्ट नहीं आ रही है आनंद मोहन जी।
सर अपने माइक को थोड़ा सर उधर से म्यूट कर लीजिएगा सर।
माइक को थोड़ा सर म्यूट कर लीजिएगा सर अपना। जी जी धन्यवाद, धन्यवाद सर, बहुत बहुत धन्यवाद। या नाउ सर स्टार्ट सर।
Okay, so thank you very much. I'm talking about the environmental damage what we did over a period of time, and this is what.
म्यूट है अरुण मोहन जी, म्यूट है। माइक को थोड़ा सा म्यूट कर लीजिएगा सर। ओके सो थैंक यू वेरी मच।
Okay, so we have to convert this situation into this situation where you have the plant converting into green, and where you do not use the toxic solvents, where you do not create the byproducts, so that you can generate lot of greenery, and you can protect the environment by practical but sustainable catalysis, by practical but sustainable practices, by practical and sustainable methods. So this is what I want to share, and this is the need of the hour. So with this, I will go into the details of my lecture. I am organic chemist, and I do some organic chemistry based on the green chemistry aspects. That's why maybe the title of the conference is Sustainable Chemistry for the Future, but I will be talking some of the aspects, some of the things which are required for the development, and also which are under practice in terms of organic chemistry. And I will be talking some of the green chemistry aspects also, and green chemistry aspects will be the part of the sustainable chemistry. So I'll start with the different definition of green chemistry. What is green chemistry and why green chemistry? So green chemistry is the utilization of a set of principles that reduces or eliminates the use or generation of hazardous substances in the design, manufacture, and applications of chemical products. So this definition was given by one of the scientists from Scripps, and some of this definition include the principles of green chemistry. So you can see here in the definition we have the utilization of a set of principles. So this set of principles are the principles involved here and given here, that is 12 principles of organic chemistry, which can be used to reduce or eliminate the use and generation. Reduce or eliminate the use or generation of hazardous substances. So you have to reduce the use of hazardous substances, or you have to eliminate the use of hazardous substances, or the generation of hazardous substances. So this definition comes from these principles, and also these 12 principles involve the design and manufacture and application of the products, okay, which will not harm or which will not damage the environment, so that we can protect the environment and we can give the greener environment in a sustainable way without damaging much to the future generations. That is what the definition of green chemistry. Why the green chemistry and what is the green chemistry? Then coming to the principles of green chemistry, many of you are the teachers, and some of you might be teaching organic chemistry, some of you might be teaching the green chemistry, and whoever is teaching green chemistry, all of you are familiar with these principles, and also some of the students at MSc level, some of the students at research level might be practicing these, some of the principles of green chemistry, they might be knowing, but I kept this slide to bring to the notice of the audience at junior level. Some of the audience might be at BSc third year level, some of the audience might be at MSc first year level, or some of the audience might be from the chemistry and allied sciences like chemical engineering. So for them, I kept these slides and I'm going to spend some time on this slide. So the principles of green chemistry are listed here, and first principle of green chemistry is prevention of the waste. What is meant by prevention of the waste? From the definition we can see here, reduce or eliminate or generation of the hazardous substance. Okay, so prevention of waste in terms of sustainability is nothing but having zero byproduct. For example, as organic chemist, I do some reaction, I transform A starting material into B product. Then while transforming A into B, depending on the reagent used or depending on the starting material used, I will be producing a byproduct. So producing the byproduct is okay, but what is meant by zero byproduct? So zero byproduct is produced byproduct should not be harmful to the environment. Produced byproduct should not be harmful to the body. Produced byproduct should not be useless. Okay, so useless means again it should not have zero commercial value. It should have some commercial value, or ultimately it should be converted into some product. That is what the zero byproduct is in terms of sustainable chemistry, in terms of green chemistry, and also in terms of organic chemistry current practices. Okay, the second point in green chemistry or sustainable chemistry is design safer chemicals. We know as organic chemistry, as organic chemist, we use so many reagents, we use so many catalysts for transforming starting material A into product B. So what is meant by designing the safer chemicals? So today we have so many examples. Maybe I will be discussing some of them, but some of the reagents, some of the catalysts. Okay, so some of the organic chemistry people might be knowing that organocatalysis, where you are using the catalyst or a small organic molecule like L-proline, which is natural amino acid, as a catalyst for transforming A product into A starting material into B product. Like for the reactions, Aldol reaction or Michael reaction or Manich reaction. So your designer catalyst, that is L-proline, is produced by the body, it is a natural amino acid. That means it is a biodegradable material. That is the meaning of designer of the safer chemicals. And this L-proline is used for the transformation. And while doing the transformation also, you have to make sure that you will be designing the starting material, you will be designing the product, okay, which will be biodegradable or which will be having zero toxicity, which will not harm the environment. That is what the sustainability, okay, in terms of the design of chemicals. Not only that, reagents we use, there are so many oxidation reactions, there are so many reducing reactions. For doing the oxidation and reducing reaction, we will be using the reagents. Sometimes reagents produce so much of toxic byproduct. Okay, so it is very, very important to produce the reagent, to design the reagent which will not be toxic to the nature after the reaction. Okay, the third point in the principles of green chemistry is less hazardous chemical synthesis. So here the point less hazardous chemical synthesis means it is a general word, but it have a lot of meaning. So it is the use of less toxic starting materials. It is the generation of less toxic byproduct, and it is also the operational simplicity. What is meant by operational simplicity? So here I gave the operational simplicity is nothing but sometimes your production or sometimes your transformation of A into B may involve high temperature. Sometimes your transformation from A to B may involve colder temperature, or sometimes your A to B transformation may be exothermic. Sometimes your transformation may be endothermic. So if it is exothermic, it will be generating too much higher temperature, like 100 to 100 degrees temperature, which will be difficult to control. Or if it is endothermic, again it will be generating very much low temperature, and at that temperature your generated compound may be sustaining or not. So that is what the operational simplicity. So for doing this type of chemistry, one has to use less hazardous chemicals, or maybe the chemicals which will not generate too much temperature, the chemicals which will not generate too much lower temperature and also too much higher temperature. Not only that, operational simplicity means the storage of the material. So recently we have seen a very big accident at Visakhapatnam. So it came from the styrene. Okay, so styrene is the material, we know all the thermodynamically stable product, but there may be a storage capacity or storage mechanism for the styrene. Okay, so they did not use the mechanism properly, and somewhere that gas was leaked and it took so many lives, okay, from Visakhapatnam in and around the city. Okay, so that's where the storage is also very, very important, and that is also the part of the sustainable chemistry. Okay, and also that is also the part of the green chemistry. Okay, and next point is use of renewable feedstock. What is meant by renewable feedstock? Okay, so when you do the reaction at ton scale, multi-ton scale in the industry, so you will be using lot of organic solvent. Like you have the benzene, you have the toluene, you have the acetone, you have ethanol, methanol, so you have ethyl acetate. So there will be so many solvents used for the transformation during the reaction. Not only during the reaction, for the extraction of the desired product, so many solvents are used. Okay, so in that case, what is meant by the use of renewable feedstock? Renewable feedstock is nothing but after the process, can you regenerate that solvent? Can you regenerate? Can you reuse that solvent? Can you reuse or can you transform that solvent into the commercially valuable product? That is what the renewable feedstock is all about in terms of sustainable chemistry and in terms of green chemistry. Okay, so it is applicable for the bulk chemicals. At the same time, it is also applicable for the solvents. Then catalysis. Just now I have given the example of designer safe chemicals. So that is organocatalyst. So here we have the homogeneous catalysis, we have the heterogeneous catalysis. Homogeneous catalysis have its own advantage and disadvantage. Heterogeneous catalysis have its own advantage and disadvantage. Okay, along with that, so designing the catalyst at lower price, or designing the catalyst which will be biodegradable, designing the catalyst which will be water soluble, which will be designing the catalyst which can be recycled. We know the most of the heterocyclic, most of the heterogeneous catalysts are recyclable. Okay, so by recycling, you are not only saving the environment, you are not only saving you are not only avoiding the pollution in terms of the green chemistry and also sustainability, we will also save a lot of money. So that is the advantage of having some of the recyclable catalysts and also having some of the biodegradable catalysts. Okay, avoiding the derivatives. So some of the organ chemistry people might be knowing that for doing multi-step synthesis, you have to do the protection-deprotection sequence. So if you are practicing the protection-deprotection sequence, that means you are adding the extra steps. Say you want to have, you have the target molecule, and to synthesize the target molecule, you have the 10 steps. In the 10 steps, maybe out of 10 steps, you have the 8 steps which involve the protection-deprotection sequence. Okay, so you have the protection-deprotection means you are going to add 1 step extra. That means you are going to add a lot of chemicals extra, you are going to add a lot of money extra. That's why avoiding the derivatives is very, very important to do the chemistry. That's what the protecting group free organ synthesis. So this protecting group free organ synthesis will have a lot of relevance to the green chemistry and also to the sustainable chemistry. Okay, atom economy. So what is this atom economy? Atom economy is nothing but you have the starting material, say 100 tons of starting material, and that 100 tons of starting material is converted into 100 tons of product. Okay, without losing even a single molecule, without losing a single molecule. So classical example we have for this atom economy is a Diels-Alder reaction. So you know the Diels-Alder reaction. In Diels-Alder reaction you have diene and dienophile, and you are taking diene and dienophile and you are just providing the energy in the form of heat. It is a cycloaddition reaction, and it is giving the cyclic product without losing even a single molecule from the starting material. That means if you are using 100 tons of starting material, you are going to end up with 100 tons of product. That is what the maximum atom economy is all about. Not only that, we have classical example, photosynthesis. Photosynthesis, we have carbon dioxide, we have water, and in presence of light, photosynthesis will be producing the carbohydrate. Okay, so that is also classical example for the 100% atom economy, maximum atom economy. So this atom economy is having a lot of relevance for the sustainable chemistry, for the sustainable green chemistry, for the sustainable chemistry. Okay, so like that. Then you have the safer chemicals. Already I have mentioned about the less hazardous chemicals, designer safer chemicals, and also renewable feedstock. All these comes under the safer chemicals. But here the safer chemicals is nothing but the production of the safer chemical. So whatever you produce, today we are talking about biodegradable materials. Just now in the introduction, sir was mentioning about PPE kits. Okay, so today entire world is facing this pandemic condition. We are looking towards the safer materials to use. We are using so many masks. Okay, so is that mask made up of the biodegradable material? Can the mask be converted into some other product without creating creating much toxic gases, or without creating much toxic byproduct? Okay, can we use these PPE kits? Are the PPE kits biodegradable? Can we just dig into the ground so that some of the microorganisms present in the ground, or some of the enzymatic reactions present in the ground will be degrading the products? Okay, so like that. So this is what the safer chemicals, production of the safer chemicals for the development of for the sustainable development, for the environmental production. So this is also one of the important point in the principles of green chemistry. Energy efficiency. So this is what I was talking about. Okay, so under the operational simplicity, operational efficacy. Okay, sir, I have a personal request here. I am sharing my screen. I cannot see you. Okay, sometimes my screen will be inactive, or sometimes my screen will be going away from your screen. Okay, if it is like that, one of you kindly speak to me. I cannot see your messages. If you put the message in chat box, I cannot see. So kindly unmute your mic and speak to me. Okay, so that I will be activating my screen.
It is visible, sir.
Okay, if it is visible, okay.
Yes, 12 principles are given on your screen, sir.
Okay, if it is visible, that's fine. If it is not visible, so please unmute your mic and you speak to me. Okay. Okay, so designing safer chemicals, energy efficiency. See, today energy efficiency, we know as organ chemistry people, for every reaction, if it is requiring some heat, okay, we provide the heat in terms of in the form of by using the heating mantle or by using the oil bath. Okay, but we have the classical example of photosynthesis. Photosynthesis uses the energy. Okay, energy which is available in the electromagnetic spectrum, the energy which is available in the visible radiation. Okay, so if we develop some process which uses the energy which is available in the electromagnetic spectrum, the energy which is available in the visible radiation, okay, that is what the energy efficiency is all about, and that have a lot of relevance for the sustainable chemistry, that have a lot of relevance for the green chemistry. Okay, and today we have so many. I think Prakash Jha is going to speak on photoredox catalysis. Okay, so maybe he will be covering. I also have these slides on photoredox catalysis. We use nanomaterial. Nanomaterial will be absorbing the energy and it will be used as an energy storage material, and that catalyst will be used for converting some of the starting materials into products. That is what the energy efficiency in terms of sustainable chemistry. Okay, so designing chemicals for the degradation. So you have biodegradable material, you have to have biodegradable material. Now we have reached to a level where we cannot live without using the plastic in our day-to-day life. Okay, we have lived in the era of plastics. Today we are talking about biodegradable plastic. Today we are talking about PPE kit which is biodegradable. Today we are talking about a mask which is biodegradable. Okay, so we have to develop a chemical, we have to develop a material which can be used for the development of this fabric, for the development of this material which will be decreasing, which will be decreasing automatically without using further process. Okay, so real-time analysis for the pollution prevention. So this is very important topic, and real-time analysis is nothing but quantification of the effluent generated from the industry, quantification of the gases generated by the processes, quantification of environmental pollution, quantification of water pollution, quantification of soil pollution. For everything we have to have quantification. Okay, that's where the real-time analysis. Without having real-time analysis, we cannot know. Till now, till recent times, we were talking about the ozone layer depletion. Okay, today fortunately the depletion of ozone layer is becoming zero. Okay, because of the policies taken by UNO, because of policies taken and practiced by different countries in the world. Okay, so it is very important to have the analysis for every damage of the environment. That's where we are going to save. We have to have the data. Okay, and last point is inherently safer chemicals. Inherently safer chemicals means again prevention of the byproduct, and all these points are having relevance with the chemistry. All these points are having the relevance with the sustainable chemistry. That's why just I thought I will share these to you in the context of today's conference. Okay, then what are the approaches? So there are different approaches for the organic synthesis. I am organic chemist, and definitely I will be talking a little bit more on organic chemistry. So for this organic chemistry, we have to have the sustainable approaches. What are these sustainable approaches? So these sustainable approaches are the use of alternative reaction medium, the use of alternative reaction medium, or the use of alternative approaches. See here, I have given a couple of points. The use of water. For example, you want to use benzene as a solvent for your transformation. For example, you want to use acetic acid as a solvent for your transformation. But instead of acetic acid, can you use water as a solvent for organic chemistry? Okay. So as alternative reaction medium. Okay. And also, can we develop some alternative alternative reaction media? Some of you might be knowing that ionic liquids are alternative organic reaction media. Okay. Lactate esters or eutectic solvents are alternative reaction media. Use of supercritical carbon dioxide is alternative reaction medium. Fluorous phases are alternative reaction medium. So water, ionic liquid, lactate esters are eutectic solvents, and supercritical fluorous material, all these are alternative reaction medium. And can there be any approach, alternative approach? See here, this is no solvent. I don't want to use this solvent. Today we teach to organic chemistry people, we teach to MSc level students, okay, solvent-free organic reactions. We publish so much of solvent-free organic reactions. So that is what the approach, alternative approach to organic synthesis, or maybe conventional organic synthesis. That's what the solvent-free approach reactions. Solid supported reactions and catalysts, biocatalysis, enzyme catalysis, etc. So all these things are part of the alternative solvents and reaction mediums. Not only that, along with that, so we also have the reaction conditions. Reaction conditions are energy sources. So just now I have mentioned, if you want to do the reaction in the laboratory, if you want to do the reaction in the milligram scale or multigram scale or kilogram scale or the ton scale, what is the conventional way of using the energy? Conventional way of using the energy in the laboratory, we use heating mantle. In the laboratory, we use oil bath. Okay. Similarly, in the industry, they will be using the water steam if the required temperature is below 100 degrees or 100 degrees, or they will be using the oil tanks, preheated oil for the heating of the reaction in the industry. Or there may be a facility where you can use the heating coil, okay, similar to your heating mantle, and that can be used as energy for the for doing the reaction in the industry. Okay, so that is what the conventional energy source. Okay, today we are talking about the use of microwave irradiation. So it is one of the big topic in organ chemistry. The use of ultrasound irradiation. This is also one of the topic in organ chemistry. So mechanochemistry, this is the latest technique developed from last couple of years. Okay, so for doing organ synthesis. Okay, mechanochemistry, grinding, ball milling. Okay, so these are some of the approaches, and these two, photocatalysis and micro reactors and flow reactors, this is the addition from last 2 to 3 years in the literature. Okay, so photocatalysis is the use of nanomaterials, as I mentioned just a couple of minutes back. Okay, use of nanomaterials for organic transformation. Micro reactors is use of a tiny material as a reactor, okay, for efficient organic synthesis. Flow reactors, use of flow chemistry, flow reactors is in an efficient way, so for the organic reactions. So these are some of the techniques which are used for the organ synthesis, and these are some of the sustainable approaches, and these are some of the future technologies for the organ chemistry. Okay, then when you talk about the solvent, how to select the solvent? What are the criteria for selecting the solvents? Okay, so we are talking about the principles of green chemistry and how to select the solvent. To select the solvent, what is the solvent, ideal solvent for the organic reactions? Obviously, water is the ideal solvent because it is natural abundance, more naturally abundant. It is less volatile. It is safe. It is green solvent. Cost effectiveness is there. So many parameters are there. But along with the water, can we use other solvents? Okay. So here I gave some of the ideal solvents: acetone, ethanol, propanol. Okay, butanol, tertiary butanol. Some of them are alcohol-based solvents are there along with the water, and ethyl acetate, isopropyl acetate. Okay, and ethyl methyl ketone are there. See, one of the basic criteria for selecting the solvent at industrial level in terms of sustainable approach. I am talking about sustainable approach. Okay, so I may not be talking about the technology, but I am talking about the sustainable approach. What is the current practice and what should be the practice of future to safeguard our environment, okay, in a sustainable way. Okay, so here if you use water, there is no problem at all. But if you use other solvents instead of water, so these are some of them are water soluble. Okay, propanol, ethanol, methanol, propanol. Okay, so 2-propanol, 1-propanol, butanol, tertiary butanol, these all are water soluble. Ethyl acetate, though it is not water soluble, it may degrade into acetic acid and ethanol. So when it is degrading into ethanol and acetic acid, so both are useful materials, and also both are maybe again they can be used as ideal solvents for the organ chemistry. Okay, so isopropyl acetate will be giving isopropanol and ethanol. Okay, acetic acid. Methanol can be used. So tertiary butanol, these can be used. Ethyl methyl ketone. So when you use ethyl methyl ketone, when you use as a solvent, okay, that will be giving, okay, like your MPV reduction, there is a reaction. Okay, ethyl methyl ketone can be converted into isopropanol. Isopropanol can be converted into ethyl methyl ketone. So that means whether you are producing the byproduct in the form of 2-propanol or isopropanol, so that can be converted into ethyl methyl ketone, and ethyl methyl ketone can be converted into isopropanol. So in a reversible reaction, that's why it is ideal solvent for the organic synthesis at multi-ton scale reaction in the industry. Okay, there are moderately preferred solvents. So cyclohexane, heptane, toluene are there. Methyl cyclohexane are there. Isooctane are there. Acetonitrile are there. Okay, some of the xylenes, isoacetic acid are there. But at the end, you have some of the solvents which are not preferred at all. Why these are not preferred? See here, there is a benzene. We know benzene is a carcinogenic material. Entire world banned using benzene for the organ synthesis. Dimethoxyethane, dioxane, these are carcinogenic materials. Pyridine, when you use pyridine for organic chemistry, and if you are getting exposed for prolonged time, it will induce male infertility. N-methylpyrrolidine, it will induce male infertility. Dimethyl formamide, okay, it is toxic in nature. Chloroform, dichloromethane, carbon tetrachloride, these are carcinogenic materials. Pentane, hexane, these are aliphatic materials, and when you are using pentane and hexane, when you drop on your skin, they are maybe the terminal carbon of pentane and terminal carbon of hexane will absorb in the skin, and because of the enzymatic reaction, they will be converting into carboxylic acid. And carboxylic acids can absorb in the skin very easily. And these carboxylic acids are toxic to the health. That's why these are not preferred solvents for organic chemistry. Okay? Then water is top, and here carbon tetrachloride, and these are the least preferred solvents. Okay, then I will be talking for a few minutes about the water, what is the importance, how the reactions are done, and some of the examples. So why water for organic reactions? Why water for organic reactions? Okay, so water is used for organic reactions because there are so many advantages. There are so many advantages of use of water. Okay, then we know that water is naturally abundant. It will not cost much. It is safe. It is environmentally benign, and it is non-volatile in nature. So because of these advantages, we use water for organic reactions. It is well established from decades. There are so many reactions which are used by using water as a solvent. However, there is a disadvantage. What is the disadvantage? Every reaction cannot be used, or for every reaction, water cannot be used as a solvent. What type of reaction water cannot be used as a solvent? Okay. For example, you have a ketone. Any ketone, and you want to convert that ketone into alcohol. And as a basic organic chemist, what comes in my mind? Okay, so the reagent which comes in my mind is sodium borohydride. And say you are using sodium borohydride and your reaction is not working. Then next reagent what comes to my mind is lithium aluminum hydride. So sodium borohydride, lithium aluminum hydride, both can be used for the reduction of ketone into alcohol, but can they be used in presence of water? Are they be used in presence of water? Okay, they cannot be used in presence of water. Why they cannot be used in presence of water? Sodium borohydride is less reactive, and sodium borohydride can be used in presence of water, but lithium aluminum hydride cannot be used in presence of water, because lithium aluminum hydride will react violently with water, and there will be hydrogen gas production, and will be coming in contact with oxygen, and that oxygen will be generating hydrogen and oxygen, they will be generating the fire, and there will be accident. That's why water cannot be used for every reaction, though it is naturally abundant. There are so many advantages of use of water, but water cannot be used for certain reactions. We have to know what type of reactions, what type of reagents water can be used as a solvent for the transformation, and for what reagents water cannot be used as a solvent for the transformation. It is very, very important to know about the use of the water. Then we know as organic chemists, most of the organic solvents, organic compounds are not soluble in water. Okay, so here just now I have mentioned there are so many reactions which can be used, okay, in presence of water, or in which water can be used as a solvent. But I am giving the statement which is contradicting with my earlier statement. What is my earlier statement? My earlier statement is many of the organic reactions are done in water. And now I am showing a statement which is substances do not interact unless dissolved. Okay, this is what we know. And most of the organic compounds are not soluble in water. Then how the water is going to be used for the organic transformations? Okay, so for that there is a very famous Sharpless. Okay, we know Sharpless epoxidation reaction, who is a Nobel laureate. Okay, who is in where he works? He is in Harvard University. Okay, so he started working on water. Okay, and they found that a new concept for the use of water for the organic reactions. They did couple of reactions and they found that water can be used as a reaction solvent for the organic transformations. Okay, after their observations, practical observations, okay, they gave a statement. What is that statement? They gave a statement saying that substantial rate acceleration when insoluble reactants are stirred in aqueous suspension denotes as on water catalysis or on water conditions. What is meant by this statement? This statement is having relevance with this statement. What is that? Most of the organic compounds are insoluble in water, and substances, unless they are soluble in water, they will not be reacting. But in continuation with this statement, Sharpless and his research group, they gave one more statement. What is the statement? Substantial rate can be accelerated when insoluble reactants are compound, and there is some interaction between water and organic compound, that is hydrophobic interaction. That is hydrophobic interaction. Okay, and because of that hydrophobic interaction, this water and your organic molecule will be forming this suspension, and this suspension will be helping to increase the rate of the reaction, and the increased rate of the reaction is called as reaction on water. Reaction on water. So from where they gave this statement? They gave this statement from this reaction. Okay, so this is narbornin derivative. It is not narbornin, but it is narbornin related derivative, and it is diethyl azo dicarboxylate. This is diethyl, ethyl, and azo, and it is ester, dicarboxylate, diethyl azo dicarboxylate. They did cycloaddition reaction between this narbornin derivative and azo dicarboxylate, and they got this product. You can see here, they did the neat reaction at 0 degrees temperature, and in 2 hours it did not give any yield. They did the neat reaction. The neat reaction means without using any solvent. Okay, and at this concentration, they heated at room temperature. In 48 hours, it gave 85%. 48 hours, you can see here. Okay, in Tolvin they did the reaction at this concentration. At 80 degrees, in 24 hours, they got 74% yield. 85% yield, 74% yield, still it is good. But they did the reaction in water. They did the reaction in water at this concentration again, and at room temperature more or less, and the reaction got in 10 minutes with 82% yield. With 82% yield. See, when they did the neat reaction in 48 hours, they got 85% yield. When they did the reaction in water, in 10 minutes, they did the yield. So I want some of you to speak, and what is the relevance between the use of water, and what is the relevance between today's topic of this international conference, international webinar, and this reaction? See, we are talking about the sustainability, right? So sustainability. Why I want you to correlate every word, whatever, every slide, whatever I am talking, every topic, whatever I am talking, in terms of sustainable development, sustainability, sustainable chemistry, sustainable development, sustainable environment, something like that. Okay. So here, I want you to understand, to do the reaction at room temperature, okay, it took 48 hours. To do the reaction in Tolvin, it took 80 degrees temperature. You need heating, you need some resources to do the reaction under heating condition. Still it is 24 hours. But you have the solvent, you have the green solvent, you have the plenty of water, you are doing the reaction at room temperature, and you are doing the reaction at in 10 minutes with 82% yield. Now, I want you to understand, this is 48 hours, this is 24 hours, okay? And this is 10 minutes reaction. 10 minutes reactions, you got 82% yield, and in 24 hours reaction, or in 24 hours, in 24 hours, how many 10 minutes reaction you can do? How many 10 minutes reactions you can do? You have the 10 minutes into 6, that is 60 minutes. Okay, that means in 1 hour you can do 6 reactions. Okay, in 1 hour you can do 6 reactions, and 6 into 24. 6 into 24. Okay, that means you can do 132 reactions in 24 hours. You can do 132 reactions in 10 minutes in 24 hours. So that is the advantage of water. That is the advantage of using water for the organic reaction. Okay. So now there are so many reactions. There is a on-water concept, well-established on-water concept. Okay, and different types of reactions are being used for the organic transformations. Maybe because of lack of time, I am not going to go into the details. But here you see different concentrations, different solvents they used. None of them gave the yield, but water gave the yield at this concentration. That is the use of the water as a solvent for organic reaction. Okay, so they have studied the kinetics also. Let us not get into it. Then how this water works as a solvent. So this is the water moiety, and this is how your water is going to have intermolecular hydrogen bonding, and this is what the aggregation, this is what the emulsion formation. So here you have the organic molecule because of the hydrophobic interactions. Okay, because of the hydrophobic and anti-hydrophobic interactions, your water will be surrounding the organic molecule, and this water molecule will be entering into the water molecules. Okay, and this induces the hydrophobic interaction, and also hydrophobic anti-hydrophobic interactions, and also this polar network of the water molecule will be helping to accelerate the reaction. So not only that, this is the assumption.
Summarize करना चाहेंगे.
And this is the
है आपका, लेकिन हम लोग फिर कभी आपको सुनना चाहेंगे.
Okay, so this is the experimental result.
और हमारे साथ मोहन कुलपति महोदय ने बहुत मुश्किल से समय निकाला है हमारे लिए.
जी आप मुझसे बात कर रहे हैं?
जी नमस्कार सर.
Okay.
You are requested to conclude, sir. Our Honourable Vice Chancellor is waiting more than half hour, and he is scheduled a new program. So please, sir, and next time you are definitely welcome for our program.
Okay.
Please, sir.
Okay. So just I will take only 2 minutes to explain this concept, and I will stop. Okay. So see here, hydrophobic and anti-hydrophobic effects. So how this hydrophobic and anti-hydrophobic effect is going to have the influence. So when you have the water molecule, you have the starting material, you have the starting material A and B, and if the reaction is on surface, okay, so this is the rate of the reaction. This is the rate of the reaction. And when you have the starting material A, starting material B, and when one of the starting material is surrounded by water molecules, this is the kinetics of the reaction. So here 1.5 into 10 to the power 5 is the rate of the reaction. If this is the mechanism, and 600 times you are increasing the rate of the reaction if this is the mechanism. This is what the on-water concept. Just I will show you only one example. All the reactions are done in water. See, even complex products are done in water. Okay, so this is what on-water concept. Actually, I had. See, you can see I have 77 slides, but because of lack of time, maybe I cannot go for that. With this, I will stop my presentation, and I thank the organizers, the Vice Chancellor, the Principal of the college, and the Head of the department, and also the organizing committee, and also some of the invited speakers of this webinar, okay, and also the attendees of this webinar. I thank each and everyone, and I am stopping here. So thank you very much. Sir, over to you.
काशीनाथ सर का, और काशीनाथ का जैसा कि आप जानते हैं कि मतलब होता है महादेव, शिव, और शिव का जो पूरा व्यक्तित्व है वही सस्टेनेबल डेवलपमेंट का प्रतीक है और सस्टेनेबल केमिस्ट्री का प्रतीक है। प्रकृति पर्यावरण के साथ जुड़ा हुआ व्यक्तित्व शिव है, तो कहीं ना कहीं हमें उस ओर जाना होगा। और हमारे साथ आप सभी जानते हैं कि काशी हिंदू विश्वविद्यालय की स्थापना महामना पंडित मदन मोहन मालवीय ने की थी, और उसी तरह कोसी के इस धरती पर शिक्षा के अलग जगाने में महामना कीर्ति नारायण मंडल साहब की महती भूमिका रही है, और उन्होंने ही हमारे इस महाविद्यालय की स्थापना की, जिसके कारण आज हम लोग उपस्थित हुए हैं। यदि कीर्ति नारायण मंडल नहीं होते तो शायद आज मधेपुरा में यह विश्वविद्यालय भी नहीं होता और आज यह कार्यक्रम भी आयोजित नहीं हो रहा होता। इसलिए कीर्ति नारायण मंडल साहब के प्रति कृतज्ञता ज्ञापित करने के लिए मैं आज के हमारे इस कार्यक्रम के उद्घाटन करता माननीय कुलपति महोदय, प्रधानाचार्य महोदय एवं सभी अतिथियों से अनुरोध करता हूँ वो आए और महामना कीर्ति नारायण मंडल साहब के चित्र पर पुष्पांजलि करें। माननीय कुलपति महोदय, BNMU के महासचिव साहब, NSS के विश्वविद्यालय समन्वयक साहब, सभी शिक्षकों से आग्रह है कि महामना कीर्ति नारायण मंडल साहब के चित्र पर पुष्पांजलि कर हम उनके प्रति कृतज्ञता ज्ञापित करते हैं। मैं आप सबों को बताना चाहता हूँ, यही वो महामना है जिन्होंने अपनी पूरी संपत्ति मधेपुरा और कोसी में शिक्षा के अलग जगाने के लिए दान दे दी, और यहाँ पर कई शिक्षण संस्थानों की स्थापना की, जिसमें यह TP कॉलेज मधेपुरा भी एक है, जिसके गर्भ से BN मंडल विश्वविद्यालय का भी जन्म हुआ है। अब मैं बिना समय गंवाए हमारे आज के इस कार्यक्रम के उद्घाटन करता BN मंडल विश्वविद्यालय के माननीय कुलपति, दर्शन शास्त्र के जाने माने विद्वान, कई पुस्तकों के लेखक और बिहार दर्शन परिषद एवं अखिल भारतीय दर्शन परिषद में कई महत्वपूर्ण जिम्मेदारियों को जिन्होंने निभाया है, और हमारा सौभाग्य है कि इन्होंने भी काशी हिंदू विश्वविद्यालय से ही पढ़ाई भी की है। इसलिए काशी का यह सहयोग निश्चित रूप से हमारे देश के विकास में और सस्टेनेबल डेवलपमेंट की दिशा में भी अग्रसर होगा। मैं माननीय कुलपति महोदय को सम्मान के साथ आमंत्रित करता हूँ वो आए और आज के इस कार्यक्रम में अपना उद्घाटन वक्तव्य दें। माननीय कुलपति महोदय।
बड़े हर्ष की बात है कि आज जिस वेबिनार में आप लोग उपस्थित हैं, यह वेबिनार अंतर्राष्ट्रीय है। कहने का हमारे अभिप्राय ये है कि आज उन समस्याओं का समाधान एक अंतर्राष्ट्रीय स्तर का समाधान होगा। इसलिए वेबिनार अत्यंत महत्वपूर्ण होने के साथ साथ शिक्षा के क्षेत्र में या जिन समस्याओं को से रूबरू होकर के ये वेबिनार का आयोजन किया गया है वह अत्यंत ही महत्वपूर्ण है, और हम लोगों के लिए संतोष इस रूप में दे रहा है। इस वेबिनार से जो कुछ भी निष्कर्ष सामने आएंगे वो राष्ट्रीय नहीं बल्कि अंतर्राष्ट्रीय पटल की शोभा बढ़ाएंगे। आज के इस अंतरराष्ट्रीय वेबिनार के स्वागत करता के रूप में हमारे बीच प्रोफेसर डॉक्टर BN ओझा साहब, प्रेसिडेंट दर्शन परिषद बिहार, हमारे बीच डॉक्टर काशीनाथ के एसोसिएट प्रोफेसर डिपार्टमेंट ऑफ केमिस्ट्री IIT वारंगल, डॉक्टर प्रकाश संध्या, डीन ऑफ स्कूल ऑफ अप्लाइड मटेरियल साइंस, सेंट्रल यूनिवर्सिटी गुजरात, और डॉक्टर BD त्रिपाठी, हेड डिपार्टमेंट ऑफ केमिस्ट्री MK कॉलेज BNMU दरभंगा, डॉक्टर N अरुल मुरुगन, एसोसिएट प्रोफेसर KTS रॉयल इंस्टीट्यूट ऑफ टेक्नोलॉजी स्वीडन, प्रोफेसर नरेश कुमार, यूनिवर्सिटी डिपार्टमेंट ऑफ केमिस्ट्री बीएनमंडल यूनिवर्सिटी मधेपुरा, डॉक्टर श्यामा किशोर, जनरल सेक्रेटरी दर्शन परिषद बिहार, डॉक्टर सुधांशु देकर PRO, डिप्टी रजिस्ट्रार एकेडमिक बीएनमंडल यूनिवर्सिटी मधेपुरा, डॉक्टर आनंद मोहन झा, गेस्ट असिस्टेंट प्रोफेसर केमिस्ट्री बीएनमंडल यूनिवर्सिटी मधेपुरा। आज इस वेबिनार के इन सम्मानित वक्ताओं का नाम मैंने आप लोगों के सामने लिया। ये सभी व्यक्ति सम्मानित होने के साथ साथ एक राष्ट्रीय और अंतर्राष्ट्रीय ख्याति प्राप्त विद्वान भी हैं, और मुझे पूरा उम्मीद है कि उनके वक्तव्यों से जो भी डिस्कस सामने आएंगे वो हम लोगों को लाभान्वित करेंगे। इसके साथ साथ यहाँ पर उपस्थित हमारे सभागार में जितने भी सदस्य उपस्थित हैं, आप सभी को हम इस उद्घाटन सत्र में आप लोगों का हार्दिक स्वागत करते हैं, आप लोगों को धन्यवाद भी देते हैं। हमारे बीच इस TP कॉलेज मधेपुरा के यशस्वी प्रधानाचार्य डॉक्टर KP यादव साहब उपस्थित हैं, जिनके निर्देशन में ही ये वेबिनार की श्रृंखलाएं चल रही हैं। आज इस अंतर्राष्ट्रीय वेबिनार को आयोजित करने का श्रेय उन्हीं को जाता है। इस महामना कीर्ति नारायण मंडल साहब की धरती पर स्थापित यह वीर मंडल विश्वविद्यालय अपने बहुत सारे सुकृतियों यानी अच्छे कारनामों के नाम से जाना जाता है। लॉकडाउन की अवधि में हम लोगों ने जिस तरह से ऑनलाइन एजुकेशन दिया है, या जिस तरह से वेबिनार का आयोजन करके विभिन्न समस्याओं पर विचार, अर्थ के क्षेत्र में, राजनीति के क्षेत्र में निश्चित रूप से एक लाभकारी सिद्ध होगा। एक समायोजित रूप में हम लोग अपने विचारों को सामने लेके आएंगे। आज के वेबिनार का विषय है सस्टेनेबल केमिस्ट्री फॉर द फ्यूचर, अर्थात भविष्य के लिए स्थायी रसायन विज्ञान। मान्यवर, आज का विषय बहुत ही प्रासंगिक है, जो इस रूप में है कि भविष्य के लिए अस्थायी रसायन विज्ञान। हम मनुष्य हैं, आप जानते हैं कि हम सभी को अपने भविष्य को लेकर कितनी चिंता रहती है। मैं उम्मीद करता हूं कि छात्र जीवन से जब से आप लोग सुनने समझने लायक होते हैं, तभी से आप लोग अपने भविष्य को लेकर के चिंतित रहते हैं। वो आपका भविष्य चाहे आपको नौकरी के लिए चिंतित करता हो, चाहे व्यापार के लिए चिंतित करता हो, या किसी भी क्षेत्र में जाने के लिए, अपने को स्थापित करने के लिए, या अपने को एक इस रूप में स्थापित करें कि हमारा जीवन सुचारू रूप से चल सके। तो एक जिस अस्थायी विकास की चर्चा भविष्य के लिए इस वेबिनार के माध्यम से किया जा रहा है, इसके अंतर्गत हमको आपको ये सीख लेने की आवश्यकता है कि हम अपने भविष्य मीन्स मानवता के भविष्य को, अपने भविष्य मीन्स एक ऐसे जगत की संरचना की भविष्य की चिंता। हम आप क्योंकि सामाजिक प्राणी हैं, बुद्धिजीवी प्राणी हैं, इसलिए हमको आपको होती है कि हमारा भविष्य मीन्स मानवता का भविष्य कैसा, जिससे कि हम सभी लोग सुरक्षित रहें। मानव क्या है? प्रकृति का एक अंग है। इस प्रकृति में पशु पंछी पेड़ पौधे नदी नाले झील झरने सबका जैसे अस्तित्व है, ठीक उसी प्रकार से भी प्रकृति में मानव का भी अस्तित्व है। मानव अपने को प्रकृति का सिरमौर समझने लगा, प्रकृति का दोहन शुरू किया, पर्यावरण को विध्वंस करने की तरफ आगे बढ़ा, या आप कह सकते हैं कि बहुत कुछ उसने विध्वंस कर दिया। किसके लिए? इसका छोटा सा उत्तर आप दे सकते हैं, अपने विकास के लिए, अपनी प्रगति के लिए। ठीक, मैं जानना चाहूंगा आपसे कि क्या वो प्रकृति का इतना विध्वंस करके, पर्यावरण का इतना दोहन करके जिस विकास पर वो पहुंचा है, क्या यह विकास उसके लिए शांतिदायक है, उसे शांति प्रदान कर रहा है? उत्तर मिलेगा नहीं। तो ऐसे विकास से क्या फायदा जिस विकास को करने के लिए आपने प्रकृति का विध्वंस कर दिया? आपने उस मनोरम प्रकृति का विध्वंस किया जिस प्रकृति के आप एक अंग है, जो प्रकृति आपको पैदा किया है, आपका पालन पोषण कर रही है, उस प्रकृति को तो आपने विध्वंस कर दिया। किसके लिए विध्वंस किया? अपनी प्रगति के लिए विध्वंस किया। तो क्या इतना बड़ा विध्वंस करके आपने जो विकास किया, उस विकास से क्या आपको सुख मिल रहा है? उत्तर मिलेगा नहीं। आपको जानना चाहिए कि जिसे हम शांति कहते हैं, सही माने में जो शांति है, क्या उसे आप विध्वंस करके प्राप्त कर सकते हैं? उत्तर मिलता है नहीं। उसे आप विध्वंस करके कदापि नहीं प्राप्त कर सकते हैं। तो आज हमको, आपको, या इस जगत में जो बुद्धिजीवी प्राणी हैं, उन्हें इस बात पर विचार करना है कि हम भविष्य में किस तरह के विकास की स्थापना करें या किस तरह का विकास करें ताकि हमारा पर्यावरण भी सुरक्षित है, प्रकृति के सभी जितने भी पशु पंछी जीव जंतु पेड़ पौधे पहाड़ नाले हैं सब सुरक्षित रहें और हम विकास भी करते रहें, विकसित भी हो। आज विज्ञान और प्रौद्योगिकी के क्षेत्र में हम लोग बहुत आगे बढ़ गए हैं। आपको याद होगा हम कहाँ थे और कहाँ चले गए। यानी विकास का जो हमारा स्तर है, विकास का जो हम कितनी ऊंचाई पर हम विकास करके कितनी ऊंचाई तक हम पहुंच गए हैं, लेकिन मिला क्या हमको? विकास की ऊंचाई पर पहुंचकर आपने पाया क्या? कोरोना को पाया। और हमें उम्मीद है कि अगर आप लोग या हम मानव अपने विकास का एक ऐसा रास्ता नहीं ढूंढेंगे जिस रास्ते में सब लोग सुरक्षित रहें और हम विकास भी करते रहें, तो कोरोना के बाद कुछ और भी आ सकता है। लीजिए, संपूर्ण विश्व त्रस्त है इस महामारी से और इसका कोई समुचित इलाज नहीं हो पा रहा है। जो बातें सामने आ रही हैं उससे ये प्रमाणित होता है, ये ध्वनित होता है कि हमें अपनी संस्कृति की तरफ, हमें अपनी भारतीय सभ्यता संस्कृति की तरफ हमें लौटना है। तो हमें अस्थायी विकास के लिए हमें निश्चित रूप से एक फॉर्मेट तय करना होगा कि हमारा विकास भी हो और विकास कैसा हो? अस्थायी। यूं तो मानव जीवन ही सर्वमूल है, आप जानते होंगे अस्थायी तो कहाँ है। लेकिन जब हम विकास की बात करते हैं तो निश्चित रूप से एक ऐसी योजना बनाते हैं जिससे कि हम विकसित भी हों, विकास के रास्ते पर हों, विकास के शिखर की ऊपरी सतह पर पहुंचे और हमारा जो पर्यावरण है, हमारी जो प्रकृति है या हमारे साथ अन्य जो जीव जंतु पशु पक्षी पेड़ पौधे हैं वे भी सुरक्षित रहें। तो हमारे ख्याल से, मेरे विचार से अब वो समय आ गया है कि हमें निर्णय लेना पड़ेगा कि हम कैसा विकास सकते हैं। मान्यवर बंधुओं, साथियों, इस बात का निर्णय हमें और आपको ही लेना है कि हम लोग कैसे विकास की कामना करते हैं, कैसा विकास चाहते हैं। क्या हम ऐसे विकास की कामना करते हैं कि हम प्रकृति को विध्वंस कर दें और स्वयं विकासशील पुरुष रह जाए? मैं तो नहीं उम्मीद करता हूं ऐसा कोई भी मानव चाहेगा कि हम सब कुछ को विध्वंस करके अपने को विकसित रह जाए। तो हमें सामंजस्य बैठाना पड़ेगा कि हम विकास भी करें, विकसित भी हों, और हम क्या करें कि हम संपूर्ण चराचर जगत को अपने में समाहित करते हुए चले, या अपने विकास के उस दौर में सबको भी हम सुरक्षित और संरक्षित रखें। हमारी संस्कृति सर्वम खल्विदम ब्रह्म की रही है। हमारी संस्कृति ईसावास्यमिदम सर्वम की रही है। हमारी संस्कृति में कहीं कोई भेदभाव नहीं था। हम लोग पशु पक्षी पेड़ पौधे नदी नाले सबकी पूजा करते रहे हैं, और आज भी करते हैं। आप लोग जानते हैं कि नहीं कर रहे हैं? बिल्कुल कर रहे हैं। तो इससे हम ये क्या जिनकी हम पूजा कर रहे हैं उनको विध्वंस करके हम अपने विकास की बात कर सकते हैं? प्रश्न ही नहीं उठना चाहिए। तो आज चूंकि ये जो बीमारी या ये जो वायरस जिसको लेके संपूर्ण विश्व त्रस्त है, जिसको कोरोना नाम से हम आप जान रहे हैं, ये कम से कम इतनी तो आंखें हम लोगों की खोल ही दी कि हम मानव हैं, हम प्रकृति के एक अंग हैं। प्रकृति हमारी दासी नहीं है, अभी भी हमारी संरक्षण कर रही है, हमारी संरक्षक है वो। तो उसको भी हम सुरक्षित रखें, संरक्षित रखें, और हम विकास भी करें। आप लोग मेरे ख्याल से आप लोग जानते हैं कि प्रकृति जब विध्वंस करती है, क्या आपने विध्वंस की सूचना किसी को देती है? नो, देयर इज नो इंफॉर्मेशन गिवन बाय नेचर। और आप जानते हैं जितना पलक गिराने में समय लगता है आपको, उतने देर में प्रकृति चाहे तो अपने को कंट्रोल कर लेती है, अपने अस्तित्व की रक्षा कर लेती है। हम आप विध्वंस करते चले, प्रकृति का विकास करते चले, लेकिन जब ये प्रकृति ये महसूस करती है कि ये मानव जो कि हमारा एक अंग है, अब वो हमें ही विध्वंस कर रहा है, तो साथियों, मान्यवर बंधुओं, आप लोगों को जानना चाहिए कितना पलक गिराने में समय लगता है, उतने में प्रकृति अपने को कंट्रोल कर लेती है। ऐसे है, ऐसे किया, छुट्टी हो गई। आप महाराष्ट्र मुंबई को देख रहे हैं, तीन तरफ पहाड़ से घिरा है, एक तरफ समुद्र है। पहाड़ों को काट के मार्ग बनाया है, आप लोग मुंबई पहुंच जाते हैं। तीन तरफ पहाड़ से घिरा है, एक तरफ समुद्र है, और लोगों ने कहा है कि इसी तरह से यदि विकास मानव करता रहा, एक दिन मुंबई ऐसे हुआ, प्रकृति ऐसे की, कहां चला गया? समुद्र में। करते रहो विकास। मैंने खूब देखा है कि समुद्र में लोग फर्स्ट क्लास, आज की विज्ञान के इस चमत्कारी युग में, वहां पर समुद्र के ऊपर क्या बनता है, पूरा इलाका मकान बन गया है, नगर बस गया है। बहुत जो पैसे वाले हैं वो वहां जाकर के हवाई जहाज से हेलीकॉप्टर से आ रहे हैं, बाहर नौकरी कर रहे हैं, फिर हेलीकॉप्टर से आप पहुंच जा रहे हैं। ठीक है, बना लो, आप बहुत प्रगति कर चुके हो, समुद्र में बना लो, पहाड़ों को काट के बना लो, जंगलों को काट के बना लो, सब कुछ कर लो, लेकिन जब प्रकृति ये महसूस करेगी कि ये मानव हमें ही नहीं रहने दे रहा है, तो प्रकृति ऐसे है, हल्का से आपने भूकंप आया था 88-89, आपको याद है नहीं? तो वो भूकंप ऐसे ऐसे था, ऐसे ऐसे, अगर नहीं ऐसे ऐसे रहता है तो शायद हम लोग नहीं रहते। तो ऐसे ऐसे भूकंप आया, कहीं प्रकृति ने ऐसा थोड़ा सा करवट ले ली होती तब गए रात। तो प्रकृति जिसे आप विध्वंस कहते हैं, ध्यान रखिएगा, आप जानते हो कि वो प्रकृति विध्वंस नहीं करती। प्रकृति अपने अस्तित्व की रक्षा करती है, अपने जीवन के अस्तित्व की वो रक्षा करती है। कब रक्षा करती है? जब महसूस करती है कि अभी मानव हमको ही रहने नहीं देगा, ये मानव हमको मीन्स प्रकृति को ही रहने नहीं देगा, जिसका वो एक अंग है, तो प्रकृति स्ट्रगल फॉर एक्जिस्टेंस, अपने अस्तित्व की रक्षा के लिए संघर्ष करती है। तो संघर्ष की सूचना हमको आपको नहीं देती। अभी क्या बोलते हैं, ठंड की ऋतु शुरू नहीं हुई है, हम लोग अपने ऊनी कपड़े सब रखे हुए हैं, अभी अचानक प्रकृति प्रकोप कर दे, 2 घंटे के अंदर ठंडा शुरू कर दे, पता चलेगा क्या होगा, ठंड से आप लोग ठंड हो जाओगे। तो ये अगर ऐसा प्रकृति करती है तो हमें ध्यान देना चाहिए, वो अपने अस्तित्व की रक्षा के लिए करती है, वो हमारा विनाश नहीं चाह रही है, हमारा विनाश नहीं चाहती, बल्कि ये चाहती है कि मैं सुरक्षित हो जाऊं, क्योंकि ये मानव अब मुझे ही रहने नहीं दे रहा। तो मेरे कहने का अभिप्राय ये है कि हम भविष्य में अपने विकास की योजनाएं बनाएं। आप भी विकास की योजनाएं बनाते हैं, बनाइए, लेकिन ऐसी योजना नहीं बनाइएगा कि अपनी नौकरी पाने के लिए उस लोगों को आप लोग क्या बोलते हैं बलि चढ़ा देंगे। अपना विकास तो कीजिए, लेकिन विकास अस्थायी हो, एक ऐसा विकास हो जिसमें कि सभी का सभी जीवों की समान रूप से उनके अस्तित्व की रक्षा हो सके। हम प्रकृति के ही अंग हैं, अगर हम किसी का विध्वंस करके, पर्यावरण का विध्वंस करके यदि हम विकास करते हैं, विकास की बात करते हैं, तो हमको आपको सोचना चाहिए कि विकास हमारा कितना स्थायी होगा। इसका छोटा सा उत्तर है बिल्कुल अस्थायी है। हाँ, मुझे मैं इस बात का भी अनुभव कर रहा हूं कि विज्ञान, जिसे आप देख रहे हैं कि अपनी प्रगति से आज उसने सब कुछ अपनी मुट्ठी में कर लिया है। दूसरी तरफ हमारी संस्कृति, अध्यात्म, जिसकी बातें मैंने कुछ बताई, ईसावास इदम सर्वम सर्वम खलिदम ब्रह्म आत्मा सर्वभूतेषु, सृष्टि के कौन कण में कौन है, भगवान है, उनके बिना इशारे के एक पत्ता भी नहीं हिलता है, तिनका भी नहीं हिलता। दूसरी तरफ विज्ञान की अपार चकाचौंध आप देख ही रहे। आज इस प्रगति की सतह पर हम हैं, हमें पाते हैं कि हमारा विज्ञान बहुत ऊंचाई पर हमको ले जाकर के छोड़ दिया है। लेकिन क्या उस ऊंचाई पर पहुंच करके हम उस शांति को प्राप्त कर रहे हैं जिस शांति के लिए इतनी ऊंचाई पर आप गए हैं? तो मुझे ऐसा आभास हो रहा है जब वो समय आ गया है कि हम अध्यात्म का विज्ञान से समन्वय करके आगे हम प्रगति तो करें निश्चित रूप से, लेकिन वो जो विज्ञान कि अगर हम विज्ञान के अंतर्गत प्रगति करते हैं, प्रगति तो करें, लेकिन हमारी दृष्टि कैसी हो, आध्यात्मिक दृष्टि हमेशा आध्यात्मिक होगी तो किसी का विनाश नहीं करेंगे, किसी का नुकसान आप नहीं करेंगे। और अगर दृष्टि आध्यात्मिक आपकी नहीं होगी तो आप निश्चित रूप से विकास तो करेंगे, विनाश भी करेंगे। अब इसी तरह से अपने को विकास करते जाइए, कुछ लोगों का विनाश करते जाइए, तो पता चलेगा कि अंत में जिस विकास पर आप पहुंच भी गए, क्या मिला? कुछ नहीं मिला। मैं महाभारत की कहानी आप लोगों को नहीं सुनाना चाहूंगा, लेकिन आप लोग जानते होंगे सर, जब महाभारत समाप्त हो गया, सब कुछ फिनिश्ड हो गया महाभारत में, तो बचे कौन? 5 पांडव बचे, आपके विष्णु बचे, और 2-4 लोग कौन है जो काल से ही बचे थे। तो पूछा उन्होंने भगवान कृष्ण से कि क्या इसी के लिए महाभारत हुआ था? आखिर में हम लोग जो 5 लोग बचे हैं, ये 5 लोग बच के क्या करेंगे? आप बताइए, सब कुछ विध्वंस हो गया, महाभारत हो गया, युग समाप्त का हम बाज ही अगर हम लोग यही हम लोग बचे हैं, तो ऐसे महाभारत से कोई फायदा था? तो हमारे कहने का मतलब ये है कि हम प्रगति तो करें, विज्ञान के द्वारा प्रगति करें, विज्ञान के पथ पर चले, लेकिन दृष्टि कैसी हो हमारी? आध्यात्मिक, वो सर्वसमावेशी हो, सर्वोपखलिदम ब्रह्म की दृष्टि हो, आत्मा पर भूतेदि की दृष्टि हो। अब रास्ता विज्ञान को बताएगा, चलिए। तो इससे ये होगा कि हम विकास भी करेंगे और हम किसी का विनाश नहीं करेंगे। तो मेरे विचार से वो समय आ गया है जब कि हमें यह सोच लेना है कि हम विकास, अस्थायी विकास की कल्पना करें, अस्थायी विकास की योजना बनाएं, एक ऐसी योजना का, एक विकास की ऐसी योजना बनाएं जो सर्वसमावेशी हो। हम एकता की बात करते हैं, अखंडता की बात करते हैं, धार्मिक सहिष्णुता की बात करते हैं, सर्वधर्म समन्वय की बात करते हैं। क्या आप ऐसा विकास चाहते हैं कि किसी एक धर्म का विकास हो, बाकी वाले जो है? ऐसा नहीं, कदापि नहीं। सर्वधर्म समन्वय की बात करते हैं, सर्वसमावेशी है, सबको लेके चलते हैं। तो हम विकास ऐसा करें जो कि धार्मिक सहिष्णुता की तरफ आगे बढ़े, सर्वधर्म समन्वय की तरफ बढ़े, एकता की तरफ बढ़े, अखंडता की तरफ बढ़े। तो बहुत कुछ नहीं कह करके मैं आज के इस वेबिनार की सफलता की कामना करता हूं। और आज का जो विषय है ये बहुत ही, मतलब कहिए तो वर्तमान परिवेश में निश्चित रूप से हमको, आपको सोचने के लिए बाध्य करता है कि हम भविष्य में अपने विकास की योजनाएं बनाएं, लेकिन वो विकास अस्थायी हो। अस्थायी विकास के लिए मेरे विचार से हमारी दृष्टि आध्यात्मिक हो, विज्ञान के पथ पर चले अवश्य, लेकिन दृष्टि हमारी कैसी हो? आध्यात्मिक, सर्वसमावेशी हो, सबके हित की बात लेकर के हम चले। हम कभी ऐसे विकास की कल्पना न करें जिसमें किसी एक चीटी का भी विनाश सन्निहित हो। हमें ऐसा विकास चाहिए जो कि सभी के हित की बात करता हो और सबको समान रूप से लेकर के आगे बढ़ता हो। तो आज के इस वेबिनार के हमारे जो विद्वान वक्ता लोग हैं, मैं सभी सम्मान के पात्र हैं और मैं आशा करता हूं कि इन लोगों के विचार जो होंगे वो मामूलकारी होंगे और देश के साथ साथ, राष्ट्र के साथ साथ अंतरराष्ट्रीय पटल पर इनके विचार स्थापित होंगे और निश्चित रूप से हमारे विश्व के लोगों को एक नई दिशा देंगे। इन्हीं शब्दों के साथ मैं इस वेबिनार की सफलता की कामना करता हूं और हमारे जो यशस्वी प्रधानाचार्य हैं डॉक्टर यादव साहब को एक बार फिर से साधुवाद ज्ञापित करता हूं जिनके निर्देशन में धन्यवाद।
बहुत बहुत धन्यवाद सर, हम आपके आभारी हैं। आपने हमारे लिए समय निकाला और इस महाविद्यालय के प्रति आपका जो प्रेम है, आपने सहर्ष इस कार्यक्रम के आयोजन की सहमति भी प्रदान की, अनुमति दी हमें। हम लोगों ने मात्र 2 दिन पहले आपको इस कार्यक्रम के आयोजन के लिए आमंत्रण दिया और अनुमति मांगी। आपने सहर्ष सहमति प्रदान कर हम लोगों को गौरवान्वित किया है। हम आपके आभारी हैं। महाविद्यालय परिवार आपके उज्जवल भविष्य की कामना करता है, स्वस्थ जीवन की कामना करता है। और अब हम आगे के कार्यक्रम के लिए अपने छोटे भाई और केमिस्ट्री के असिस्टेंट प्रोफेसर ऑनर मोहन झा जी से आग्रह करते हैं वे आगे के कार्यक्रम का संचालन करें। फिर हम लोग बाद में अंतिम सत्र में हम लोग प्रोफेसर नरेश कुमार, जो आज के हमारे कीनोट स्पीकर भी हैं, केमिस्ट्री के डिप्लोमा प्राध्यापक और शिक्षक संघ के महासचिव भी हैं, और डॉक्टर श्यामल किशोर सर जो कि दर्शन शास्त्र के प्राध्यापक हैं और दर्शन परिषद बिहार के महामंत्री हैं, उन लोगों को हम लोग सुनेंगे। उस बीच में मोहन जी से आग्रह है आप इस कार्यक्रम का संचालन करें और निश्चित रूप से यह कार्यक्रम दर्शन और विज्ञान के बीच समन्वय स्थापित करने में मील का पत्थर साबित होगा। इसी आशा के साथ आनंद मोहन जी से आग्रह है आगे के कार्यक्रम का संचालन करें। आनंद मोहन जी।
बहुत बहुत धन्यवाद सर, आपका बहुत बहुत आभार। आप हमारे आगे कार्यक्रम के लिए, संचालन के लिए बहुत बहुत धन्यवाद। Now our next eminent speaker is Professor Dr. Prakash Chandra. I will shortly introduce him. Prakash Chandra is at present associated with Central University of Gujarat, holding multiple administrative responsibility beside being an associate professor, teacher and research scientist. He is the Dean of School of Applied Material Science, coordinator for university level industry academia interface cell, coordinator and nodal officer for Government of India, recently launched the flagship program Bachelor in Vocational Study for Rotational Approach to Drug Design at Central University of Gujarat, Gandhinagar. He is a nominated member of President of India Innovation Club at Rashtrapati Bhavan, New Delhi. Earlier, even he has served as nodal officer for the National Mission for Education through Information and Communication Technology project at Central University of Gujarat, Gandhinagar. He has a PhD from Indian Institute of Science, Bangalore, and is credited to have more than 132 international publications in the peer-reviewed journal with 1136 citations and H-index 46. He has been associated with Swedish, Norway, and Indian Academy of Science, American Chemical Society in various capacities. Professor Dr. P.C. Jha is one of the best and dynamic professor in India. I request Professor Jha to give his eminent lecture on today this international seminar cum webinar. Please, sir, you are requested to deliver your lecture. Kindly, sir.
Thank you very much for giving nice introduction, Anandji. Before I start, actually somebody is presenting it and it is very difficult to see the slides. So you have to check that part too. You are presenting to everyone, but somebody is presenting already. And that is the problem. I am not able to show my slides.
No, your slide is coming, sir.
Okay. If my slide is coming, that is all right. You can see. So
yes.
before I start, I would like to thank Honourable Vice Chancellor, Principal and Head of Department, and my special thanks goes to the Sudhanshuji and Anand Mohanji for giving me chance to speak on this platform. I belong from Bihar, and that's my responsibility to speak for my motherland too. I am also thankful to the Darshan Parishad Adhyaksh and Organizing Secretary for talking nice words. The theme of this seminar is sustainable chemistry for the future. So basically the role of chemistry in inventing a sustainable future. And in fact, recently United Nations meeting, it has been decided that there are great challenges that our planet is facing this century. And play a pivotal contribution to help realize these ambitious goals. Goals are ambitious, but chemistry can do. But if chemistry has to do, then it has to do major changes in their priorities, approach, and practices. And when we talk about priority, practices, and approaches, then first we need to understand where does the role of chemistry comes into the picture. If you look at the chemical sciences, then chemical science provides understanding of the physical and chemical properties of atoms, molecules, and practical methods for creating new molecular structures with useful applications. Chemistry is a platform, or you can say it's a central science, underpinning fundamental aspects of a range of established and emerging sciences, including biochemistry, nanoscience, molecular, synthetic biology, physics, soft condensed matter physics, as well as many major practical advances seen in such fields as agriculture, biotechnology, energy, ecology, environment, genetics, information technology, materials, medicines, everything. But as my life has become much more simpler because previous speaker, my dear friend Kasinath, has given a nice introduction about sustainability. So I will not get into that part of it, but I would like to certainly tell you in particular The chemical sciences are central for health and medicine. When you talk about health, you talk about green, clean, and sustainable form of energy. And that is possible through efficient capture of solar energy, fuel cells, carbon capture storage, and reuse. He already talked about application of green chemistry principles and process in manufacturing for materials, ensuring the efficient and affordable recycling of resources. These all can be done through chemistry. But the chemistry has to make changes in 21st century. Gone are those days when organic chemist will not talk to physical chemist or inorganic chemist or organometric chemistry or pharmacy people. Chemistry has to be multidisciplinary, interdisciplinary, and transdisciplinary if it has to sustain in 21st century. And the role has changed. It has to create a scientific knowledge. Then you ask yourself, why do you want to create a scientific knowledge? We are creating a scientific knowledge to translating this knowledge into useful applications. For example, for generation of clean energy, helping to meet, and hence this will help to meet the emergent challenges or multiple unfolding global crises. That's the chemistry. I don't belong to as such an experimental chemist. I am not an experimental chemist. I don't know how many of you know what is computational chemistry. But if you don't know, then in one sentence, it's a chemistry on computer. So modern days, you can do everything what you can do in the lab. That's what it is. And since you do in chemistry, there is no toxic material, there is no dealing with a solvent. So it is certainly a sustainable future, and it's a sustainable chemistry. And coming to the point, what I will do, I will give you a very brief introduction about the methods used in computational approaches and how these methods help in real life problems. And I will give you a few examples from my research, which will tell you how this computational chemistry can be used for solving many problems, which is certainly sustainable and green chemistry, because there is no use of chemicals at all, no carcinogenic, no toxic materials, no environmental pollutions. Coming back to the method we used, we call it multi-scale methods. Just like the different kinds of characterization technique you have in the lab, similarly in the experimental lab, you have a different kinds of phenomena. For example, if you want to capture photoionizations, the photoionization happens at the femtosecond levels. So if you have an instrument which can capture that phenomenon, you will be able to characterize that. Or if you are dealing with a proton transfer, it happens at 10 to the power minus 12 seconds. If you have an instrument to capture that, you can study proton transfers. Similarly, for any kind of molecules, compounds, polymers, proteins, we have a different methods at different level of theory. And that methods are called first principle simulations, where we don't assume anything. But the limitation with this method is the size is very, very small, means going beyond 10 atom system is next to impossible. And then what is the use of that methods? Because daily use products are certainly more than 10 atom systems. Then we have a method which is called hybrid quantum mechanical methods, and that method can be used for solving that kind of problems. If you are bigger than that, then you go for the classical simulations. So what I want to give the message from these slides, different kinds of computational methods as different level of theory. And hence, you can use the different methods for different kinds of problems at hand. So you can design your computational approaches depending on the problem at hand. Since we are running already late, so I will be running little faster and try to finish it as soon as possible. So give me 15 to 20 minutes and I will be done by that so that we can maintain the time. If you look at the scenario for predictive material simulations, on the y-axis I am showing the subjects, physics, chemistry, biology, or material science, or engineering, whatever it is. On the x-axis I am showing the length scales. If you have different kinds of systems, you can see in the boxes, depending on the size of the system, size by size I mean number of atoms or the size of the molecules, you have different methods which are written there, DFT, MD, these are the methods which is used for solving different kinds of problems. So for all kinds of problems, you have different methods. Only thing changes is the length and time scale at which it happens, that gets changed, and you use different methods for different sides of the system under the study. If I look at my research area, actually I worked on many different systems and many different schemes, but I will be concentrating on few of them. One of them, you know that in everybody's house now it is a LED TV. Earlier it used to be LCD. Before that it used to be normal TV. Now we have a LED TV. And LED, why LED, and what is the replacement of a LED TV? That is what is called organic LED, OLED. Then we talk about molecular crystals and their phase transitions. Then I will show you by taking one example that how computationally you can design the chemical reactions. Then I will another example I will show you that the simple chemical reactions takes place in the lab that is not producible at industry level where the demand is for bulk. So how do you take the simple chemical reactions with the help of enzyme to the production in the bulk? That is at industrial level, that also I will show you. Then I will show you one of the interesting and fascinating part, what is called photodynamic therapy, where the person is suffering from cancer cell, then how using the light one can operate the cancerous cells. That is what is called sensitization of cancer cells to light. Then we will talk about solvatochromic molecule as a molecular probe. These examples I will give you, although I have studied many different kinds of things. For example, modern days data storage, you have a DVD of few GB. Imagine you have a data storage of few terabytes and size will be smaller than USB. How good it will be, that kind of modeling also I have done. Then modern days energy, people are talking about new material for hydrogen powered mobile applications. I will not have time to talk about all those. I will be not talking about nanoscience, what my dear friend Kasinath was talking about, that I will be not able to talk about today, but maybe in future sometime I will talk about. So basically I worked in many different fields and these are the results, but I will concentrate only on the things, few things which is highlighted in red color. If you look at the organic light emitting diodes, the Sony has produced the first light emitting diodes using light emitting diodes, first LED TV in 2010. And 2010 LED TV's normal price for normal 20-24 inches used to be lakhs. The question was why? Why it was so expensive at that point of time and why that is cheap now, and what is the problem with the LED TV? The problem with LED TV, the mechanism by which it works. There is something called charge injection. So there was no balance charge injection. There was not sufficient carrier mobility for both an holes and electron to interact. And hence, the life expected time of the TV used to be 6 years or 7 years. And if you are investing that much money and you knowing that your TV will not work for 4 or 5 years, why you will buy it if that expensive TV? And that was the problem. And then if you look at these LED, all of them has used polymer materials, all different kinds of polymer materials, and I will show you the structure in a minute. And if you look at those polymer materials, then experimentally it has been characterized using 5 techniques: time resolved photoluminescence, excited state absorption spectroscopy, fluorescence, phosphorescence, flash photolysis, pyro-optical absorption, and UV, IR, and Raman spectroscopy. So what I am trying to tell you is the experimentalists characterize these kind of polymers using these techniques. And being a computational person, you can calculate all those, and I will show you in a minute the results, that how does it matches with the experiments. That is how it is. But whole range of polymers has been characterized by computations. Whatever polymers I am showing you, whether it's PMOT, whether it's P3O, whether it's MEH PPB, whether it's PFO, whether it's GOPPB, whether it's GHOPPB, whether it's PPY, HPPY, or any polymers, all of them we have characterized actually through the experimental work. We have studied the fluorescence-based polymers, and these are the polymers which is used for different application purpose, not only in TV, but in different kinds of display devices. If you look at the results, the green color in the left-hand side, one of them shows experiments, while another one shows theoretical calculations. As you can see, if you look at the singlet gap, whether it's experiment or theory, it matches completely. Similarly, if you look at the triplet singlet gap, experimental or theory, it matches exactly. This tells you that computation has come to the level where you can really mimic the experimental part. And that is how it has been done, and the computations, and this has been done using computers and characterizes with respect to the experiments. Just to give you an idea that predictive simulations is possible using modern computations. That is what has been shown here, and we predicted some of these properties which was important by modeling the different chain length, and the matching with the experiments and theory was pretty good, and qualitatively we predicted which kind of polymers can be used for such kind of display devices. In that same series, the electron transporting materials used earlier was oxygen derivatives, but we proposed the new materials using what is called density functional theory with Marcus theory. We try to find out the deorganizational energy, and as you can see in the lower left corner, the thiazole, which was triazole, which has been used earlier, and we proposed why thiazole can be a better candidate than triazole, and what is the benefit of using this. And this has been done through the computations, again compared with experiments, and it has been predicted quite well. Coming back to the molecular crystals, usually such kind of classic calculations are quite expensive, but you use the simple on a desktop computers NPT MC methods, which is a NPT Monte Carlo methods. And here our idea was very simple, and it was based on Occam's razor principles. It says that it is vain to do with more what can be done with less. If I can do some calculations which is qualitatively correct at a simple desktop computers, why I should burn computer power and resources for doing a higher level of calculations. So basically, through these calculations, we have shown that how the understanding of the subject and how the understanding of the methods you can use to predict the properties of molecular crystal by simple Monte Carlo simulations. And it was about the phase transitions at different pressures. And as you can see, the different cell parameters are matching quite well with experimental XRD, whether it's A, whether it's B or C. These are the different cell parameters, which is a function of pressure at 300 Kelvin. Then we have fitted it with the equation of a state, and even in equation of a state, the matching between the experiments and the theory is quite well. If it is a phase transition from one phase to another as a result of pressure, then there must be a disappearance of certain nodes. And in fact, we did the calculation where we showed IR intensity as a function of pressures. And we have shown that out of plane bending modes of hydrogen atom disappears as it changes the phase. And disappearance of this modes is certainly telling that the phase transition is taking place. So again, in case of molecular crystals also, the computational methods have been used, and it has been shown that how it can be good to go with the experiments. Even if you look at the cell parameters, everything is matching quite well, and that has been shown again by doing these calculations. I was telling you that these are the simple reactions, and from school days or other college days, you will be taught Aldol's reaction, where vinegar oxidation reactions. These are a simple reactions where you are trying to break the double bond into the saturated one. So basically what you are trying to do, you are trying to produce from double bond the saturated one, double bond. So saturated chemical compound. But the problem in the industry is you want bulk level. And these reactions, the yields are very small, what you do in the lab. And there our proposal was that if we take some enzyme, which is called lipase in this case, and if you use the lipase as a catalyst, and the same reaction under same conditions, you will get quite active yield. Here too, we have shown how it can be done, and the lipase used was Candida Antarctica lipase B, where we have shown again by taking a model of a chemical compound that what is the active site and how at the sulfur as the active sites, these kind of classifications and the breaking of bond takes place and how the mechanism takes place, and from where does the electron transfer takes place. That has been shown that what was the aspartate group does to this breaking of sulfur linkage, and hence the formation of saturated compounds. And all the transition state has been discovered, and it has been found that this reaction proceeds through 4 transition states, and all the 4 transition states has been located and found. Finally the product has been formed, that has been shown. You know, most of the pharmaceutical company across the world, at least 25% of all the drugs contain an amide unit. And if you ask what is the simplest way and efficient way or greener way to produce the amide bond, the answer is very difficult to answer. Answer is very difficult to answer. The reason is very, very simple. If you look at the literature, then you will see carboxylic acid reacts with amine. There is a formation of amide, and finally you get the amide. But there are many problems. First, their byproducts are more than the product required. Second, reaction takes place at around 160 degrees C, which is a difficult condition to maintain. Then what is the way forward? When we looked into the literature, we found that if we take acids with amine and reacts in presence of boronic acid, there is a formation of amide products. And as you can see in the extreme right bottom corner, that in a different solvents, whether you use THF or whether you use CS2Cl2, for different solvents, the percentage yield is decreasing, and in fact we have shown that up to 91% yield if you get in CS2Cl2 using the mechanism proposed by this. This we have done for some company actually, so I may not show you the detailed informations because I am not supposed to show, but what I am trying to tell you that you can model the chemical reactions using computers, and this is very routine work nowadays for a computational chemist to do, and this is possible to do. So through computation you can even model organic, inorganic or any kind of reactions. Then coming back to the next work, where we actually sensitize the cancer cell to the light. What do you see in the red picture is, you see first surgeon's hand, and what do you see in surgeon's hand in operation theater is a beam of light traveling through a fiber optic cable, and it is going and attacking the cancerous cell, and it is damaging the cancerous cell. During the surgery, the light beam is positioned at the tumor site, which then activates the drug and that kills the cancer cell. Now you can ask yourself, where is chemistry here, and how does the basic knowledge of chemistry helps? For that, you have to understand that only approved drug today is based on one photon absorption, that is a linear spectroscopy. But the problem with the linear spectroscopy is penetration depth of the cell is very, very less. So basically it does not penetrate deep inside the cell. Then what to do? Then we propose that if you take nonlinear spectroscopy, which is also called 2-photon absorption or 3-photon absorption, then you can do this because penetration depth in the tissue will be more than a half inch, and the operation can be done very easily. Operation can be done very easily. That means, where is the chemistry? Chemistry is very simple. The patient gets the photosynthesizer drug 24 to 48 hours before operation. And then when you pass the light gets into the photosynthesizer, and since oxygen is present there, so it gets converted into singlet state. And from triplet to singlets, there is a transition that takes place, and that leads to the damage of the cell, and that is what happens. And that you have been taught in school days about Jablonski diagram. So it's more or less like a Jablonski diagram. So what was the difference when we were taking one photon absorption? That is a linear spectroscopy when we are talking about. Why do we need 2 or more than 2 photon absorption? Because the problem with 1 photon absorption is absorption is at longer wavelength. Longer wavelength means lower energy. Lower energy means penetration depth will be less. High singlet oxygen yield, which we don't want. We don't want photobleaching. We want chemical stability. We want low dark toxicity. We don't want this. And that's why if you take 2 photon absorption, then all these problems gets lifted, and we will be able to do that. And in fact, we proposed one of these molecules, and that is what I will show you in the next slides. And this is what I was talking about, Jablonski diagram. Jablonski diagram is very simple. 1 photon gets excited from singlet ground state to the excited state. So instead of one, you are exciting 2 photons. Now the 2 photons you have excited, but it has an option. Either it can come back to the singlet ground state, or it can go to the triplet state. If it can go to the triplet state, it can stay there, or it can come back to the ground state. This is what is called inter-system crossing. That means you need to find out the parameters by which you can optimize the rate constant of inter-system crossing. Means you need a material for which inter-system crossing rate is high. And that is why we propose the molecule for which this has been given. And what I am showing you in photodynamic therapy is very simple. Photosensitizer has been given, laser light is passed, that gets oxygen gets activated, and then it makes the radicals, and that is in singlet oxygen. Then oxidative inquiry to the cell happens, then cell death takes place. So basically you are looking for a material by which you are optimizing the inter-system crossing rate. And that is what we did, and we tried to show that part very clearly. And in fact, we proposed the new molecules where we have shown that the 2 photon absorption is of the order of 1000 GM, which is much higher than what is accepted till date, because whatever Food and Drug Association accepts is a 1 photon absorption. But this proposal has been there that if you use 2 photon or higher photon absorptions, you will get better cross sections and hence better for the therapy purpose. That also has been done. Then the last example I am talking about is the solvatochromatic molecules. If you take the solvatochromatic molecules as a molecular probe, this is a phenyl blue, and we took the phenyl blue and then it is surrounded by water. Through this calculation, we are trying to show that how does the calculation comes close to the experiments. And in fact, what do you see here is what is called radial distribution functions, by which you are getting the cluster size, and from where we are calculating first solvation cell, second solvation cell, third solvation cell, fourth solvation cell. That is number of water molecules is decreasing. But does it lead to something which is very interesting? If you look at the left-hand side plot, you will see the phenyl blue in gas phase, then in water as a cell 1, cell 2, cell 3, cell 4. And you can see the experimental number that is 535 nanometer. In non-polar solvent is 544 to 555. And we can see that our calculation very clearly says that in the solvent, a bulk as a solvent, in the water, it's 654 and we are at 670. So it's between 654 and 684. So shift is of 135 nanometer. So by using the computations, any kind of situations can be solved and it can be modeled. And if you are using computation, it's free from chemicals and anything, any hazardous things, and that's why it's sustainable. And with this, I will stop. And once again, thank the organizer for giving me time. Thank you very much. I had less time, so I cannot continue anymore because I have another class schedule. So please forgive me for that and let me stop here. And thank you very much.
Thanks a lot, sir. Your lecture was very inspiring, wonderful, tremendous, excellent, delivered by you. You have given me time in your busy schedule, so we thanks you wholeheartedly. It's feel proud to our university that you have given a tremendous lecture and very nicely, and we always welcome you to our university. We are so much thankful to you once again. Thanks a lot, sir. Now our next speaker is Dr. N. Arul Murugan. I will shortly introduce him. He was Docent Associate Researcher, Department of Theoretical Chemistry and Biology, School of Chemistry, Biotechnology and Health, KTL Royal Institute of Technology, Stockholm, Sweden. He was Docent 2015, appointed as Docent in Theoretical Chemistry and Biology at KTS, Sweden. PhD in 2005, Computational Chemistry, SSCU, Indian Institute of Science, Bangalore. MSc in 1998, Gree Deemed University, Dindugal, India. He has 9-year experience. He had published more than 100 articles in international peer-reviewed journals, including Science Advance, JACS, JPC later, Journal of Medicinal Chemistry, Biosensor and Bioelectronic, JCTC, CAM, COM, EJ, CAM, ACS Chemical Neuroscience. He was also co-investigator in India Sweden grant funded by Dewvedi, Binova and BRSRL. He has guided, supervised more than 10 masters and PhD students and postdocs, acted as examination committee member for 15 PhD, licentiate and master thesis, delivered about 42 seminar / presentation in international conferences, universities. He has served as editorial board in Scientific Reports, Crystals and EMRS special issue of Hackham. He is also reviewer of 25 Journal of ACS, RSC, Elsevier, MDPI and Wiley publisher and completed around 121 reviews. He has awarded fellowship, FNRS postdoctoral fellowship, supported by Belgian National Fund for Scientific Research, joined the last Sierva postdoctoral fellowship. He has taught molecular bond modeling, physical biochemistry, biomolecular structure and function, drug development. He has also pedagogical training at KTS Learning Lab. He has completed pedagogical course, Teaching and Learning in Higher Education on 18th January 2016, completed course Learning for Sustainable Development on 10th June 2016, completed at pedagogical course Research Supervision offered by KTH Learning Lab on 13th June 2013. He is one of the best eminent associate professor in abroad. He is working like a scientist. He is generally a scientist. I request Professor Dr. N. Murugan sir to deliver his lecture. Please sir, you are requested. Kindly unmute your mic sir.
So you are able to hear me?
Yes sir.
Hello?
Yes sir. Yes sir, you are visible and you are audible too.
Yeah, so okay. And the slides are fine. You are able to see my slides, I guess.
No sir, your slides are not coming yet.
Okay now? No? Hello?
Now also it is not coming sir.
Got it? What is this?
Yes sir. Now it is coming sir. Your slides are coming.
Okay.
You can start sir.
Now the problem is it's not full actually. That's a problem. Okay. So anyway, so you are able to see it, I guess. So
Yes,
first
yes.
of all, thank the organizers for giving me a chance to present about my work. It's quite interesting that you are organizing international conference from your college on sustainable chemistry. That is really very interesting. I think this topic is really very important, and it is needed in time. I think that way it is. I'm very happy that I'm able to contribute. And first of all, I'm in fact previous speaker Ja and myself, we are colleagues doing PhD together in Indians of Science, and then he was also here in the same place where I am right now. So I'm very happy. You know, when he called me and asked me to give a presentation, I was very happy for that. And so today I'll be talking about sustainable drug discovery practices with the use of computers. So we have heard about sustainable chemistry from the first speaker, Kasinov. Then Ja talked about sustainable material science and optical probes, solitochromic probes modeling. So I'll be talking about the bioscience modeling and drug discovery using computers. So we call it as sustainable. I will a little bit talk about it a bit later, why we call this as sustainable as we go along. And this slide, of course, you are very familiar with. Our previous speaker, Kasinath, presented this. Like the United Nations has adopted these 17 sustainable development goals. And not only United Nations, I think we all countries, developed countries, we all need to respect this and try to do something to contribute to this subject, because it's really urgent. We are running out of resources. So it is very important that we leave the world to our upcoming generations the way that we enjoyed. They also should enjoy. So we should leave the resources as we had with us. Not only that, we also need to work on many things, like improving the working condition in developing countries. Like poverty should go, and then everyone should have equal rights, and then we should respect other human beings, and then everyone should get nutritious food. So for that, as a citizen of a country, we need to do everything possible, and we need to develop tools, or we need to work on approaches to contribute to this subject. So here, so this is something very important, and I think this conference is coming in the right time. And why this is very important, that KTH also appreciate this very much, because in the sustainability ranking, KTH is in the topmost, I think top 100, it comes in top 100 universities, which fulfill the sustainable goals requirement. And I think every universities in India also should try to adopt, introduce protocols to contribute to this subject. Like as a KTH teacher, what we do is we introduce courses, we introduce sustainability as one of the unit in our courses. So when the students do a project, so they also need to include one element, like how this project is meeting the sustainable goals recommended by the United Nations. So same thing, you can also introduce in your courses, like introduce one small model and ask the students like how the projects, what they do, will contribute to this subject of sustainable development or so on. So that is something interesting that you can consider. So many of us now talk about sustainability, but what is this? Of course, like previous speakers already mentioned a little bit about it, but let me also give some one small description about this. So there is a famous modeling software developed by MIT, where people can learn what is sustainable development. So this is called Fish Bank simulation. It is like available in this link which I had given in the bottom. You can go to that site and download, and then you can play with different groups. So what it is about is that there will be like different groups, and then they will be having access to ocean, and they can buy boats, they can go and fish wherever they want. But the thing is like so everyone should maximize their gain. Okay, so like if the commoners, if they play this game, what happens is that they tend to be very greedy, right? So they tend to go and collect lot of fishes. Then they buy a lot of ships. Okay, then what happens over a period? Of course, initially they will be gaining a lot. Each one will try to optimize the gain profit. But then you will see that after a few years, there is no fish in the ocean. Okay, then it is like totally, it ends up or the game collapses. Like everyone loses, and there is no fish in the ocean. So this is like a very good way of learning the sustainability. Like, when you want to fish, you have to think about, like, for the next year, it has to grow. So you have to leave out certain fishes so that, they can do reproduction and then produce again a bulk amount of fishes next year also. So when you are doing fishing, you have to be very careful. You should not overfish. But then the commoner, what they do is, like, they tend to overfish because they want to maximize the gain, and then they only look in terms of short-term benefits. Okay, so this is really very bad, and I think many of us do this actually. So this is not really good for long-term development. When you, after like 5 years, then your children don't have any fish to eat. So when you are doing certain thing, you have to always think whether am I doing something in a sustainable way. So whether am I overfishing, or am I doing something in a overrated way. So all these things we have to analyze, and then so we have to, not only that, when you are doing a business, then you also interact with the neighbors, make certain rules so that everyone get equal benefit, and also this benefit survive for longer time, like maybe all generations which is going to come in future. Okay, so that is the thing about sustainability. So it is very important. It is not only in chemistry, it is in every subject. We have to think about sustainable development. Okay, so now I'm going to talk about why we need to use computers and in what way they are going to help us to develop or to attain the sustainable goals. So that is what I'm going to discuss now for next few slides. So we can do science with the computers. Okay, as you can see that now the computers are used in all subjects. Like as Prakash Jha presented, you can design materials like with larger 2-photon absorption cross-section, 3-photon absorption cross-section, and materials suitable for photodynamic therapy. So these materials design you can do. In addition to that, you can do like drug design. Like now that we are in the very bad time of COVID-19 pandemic. You will see that like there are n number of papers published in the public domain. You can see them available. So all of them use like computers to screen compounds and identify compounds which are which can target certain potential targets in the virus. So these type of papers are coming. So you can use computers for doing drug design. Also, one can model protein folding, protein dynamics. Certain these processes sometimes they occur in the time scale of like microseconds to even milliseconds. But then still you can manage to model these processes using computers. Of course, the weather prediction, this you can do. Then computational fluid dynamics and molecular probes design, like as Jha mentioned, like solitochromic probes design you can do. Not only that, even you can do share market modeling, also the earthquake modeling. All these things can be done with the computers, just with the computers. But of course, not with the like what type of like laptops we have. Maybe for certain computers, for certain modeling, you really need very big supercomputers. Okay, so that we should be a little bit aware of. I'm going to little bit discuss like how we are going to do this modeling. So what do we need to do modeling? First of all, we need a theory which can describe the state of a system or a particular process, how it evolves as a function of time. So we need a theory to describe this. Then we also need a mathematical representation of the theory. Then we should be able to solve these mathematical equations numerically. Once we have all these, then we can use computers for modeling that specific problem. Okay. So many times we may have theory, but then solving it numerically is quite impossible. Like you might have come across like quantum mechanics, and then we use very complicated Schrodinger equation that we need to solve them numerically. That's like quite difficult task. But then nowadays one can do this. So we have we have handled such things nowadays. So it's not a problem. So when you want to model about something, then you need to have a theory. You need to have a mathematical representation of theory. Then you need to know how to solve this theory numerically, like using computers. Okay. So when you are talking about chemistry or materials, we basically use these theories like classical mechanics, which tells me like how the particles interact with each other. Like let it be any materials, like it can be like a wood, it can be like a sand, it can be like a rock, whatever it is. Okay, so all these things are governed by the classical mechanics. Then, when the system size goes much smaller, like hydrogen atom size, then the classical mechanics fails. Then we have something like quantum mechanics. But then at that time scale, at that length scale, then we have theory, quantum mechanics, which can explain the system in a better way. So then we have statistical mechanics, then we have continuum mechanics, then we have electrostatics. So we have certain theories to understand how the materials exist, what stabilize them to exist. So such things are available to us these days. And then when it comes to equations, these are the equations that we talk about when it comes to materials modeling or chemistry or bioscience. So we basically deal with Newton's equation of motion, time-independent Schrodinger equation, time-dependent Schrodinger equation, then constant density functional theory. Then these other equations, Poisson's equations, Maxwell equation, to talk about electrostatics. So we have these equations, in the modeling. So once we have this, we can, as I said, we can do the modeling. But then, as I said, why do we need to do modeling? The reasons are that, the experimental approaches are many times time-taking, then expensive, then sometimes destructive. Sometimes you mix two chemicals and then you come up with a new chemical, but then you have already destructed the reactants. So they are basically destructive methods. Sometimes in the lab, you mix two things and then it just explodes, and then it can be quite dangerous also. It is it can be even life-threatening. So then, as I said, nowadays it's you can model almost anything, any system, any process. Even they have come up with the supercomputers which can even model nuclear explosion. And then nowadays, you can this car smash measurements. You want to design materials, which can protect the driver. So what you need to know is that front side of the car, what type of materials you need to use. So for example, when it goes and collides with a wall or something, how that material will crack. How the shock will propagate along the materials. So all this can be modeled. Nowadays we have this crash modeling softwares. The car companies, they rather use this. Okay, then they model how the materials, how strong is the material. Then they finally, once these materials pass through this test, then at the end they will be doing this test for few cars. Okay, so basically earlier for when they need to use many cars to perform these experiments, but nowadays most of the part can be done with modeling, computers in the computers. Then later on, only few cars, then you do this test to again confirm the results. So I would like to before I go further into my topic, I would like to ask this, whatever the results we get from neutron scattering measurements, can we get them from the modeling, using computers? And then here I show you the data that of course it's quite possible, because once we are able to follow the systems at the molecular level using Newton's equation of motion. So we know the atomic position as a function of time. So once we have these positions as a function of time, you can compute any properties, it can be G of R, S of Q, or another time correlation function, anything you can calculate. And same way, we have done for 1,2-dichloroethene something, ethylene, so what I show here is the comparison. The top figure comes from the experiment, neutron scattering experiments, and then the bottom figure comes from modeling. So not only that, this has been done for, in particular, this 1,2-dichloroethylene is a very interesting system, which exhibits liquid-liquid transition. And in fact, we have done for both liquids, low density liquid and then high density liquid. You can say that the comparison is quite good. Another interesting aspect is that this calculations are done by myself, and just using desktop computers for a period of 1 week. And then, so the cost of a computer was maybe, let us say, 20,000 rupees or something. But then you see that in order to do this neutron scattering experiments, my experimental collaborators might have spent quite a lot of money and time, they have to wait in the queue, and then they have to go to Grenoble and then get timing, wait in queue, then ask the engineer to do this. So it's quite a lot of, then you collect the data, then analyze it. It's a lot of things. But then the whole modeling part was done by myself with very limited resources. So this is something very interesting. Like you can do very complicated experiments or results. You can, from what you get from experiments, you can get it with the use of simple resources. Simple use of theory and computers. So this, I think, all young people, I think, who are listening to this, to consider, whenever you see a process or whenever you see a system, you can think about, can I model it? Like, can I understand this? Why it is like that, and can I use some theory to understand it? Why it behaves that way? You always have to think about in this way. Then also, nowadays there are very many open source softwares available. You can just download them and then try to do it by yourself. Otherwise, ask experts. Nowadays, you can always just send an email, and then people from anywhere, they respond to you. So this is the way you should use your time in a very useful way. We have a lot of resources. It is not like 10-15 years ago. So now the time is very different. We have access to quite a good data and very good internet. We have a lot of resources, so we should make use of it. And anyway, let me continue further. So one was that structure, with neutron scattering instruments, what we probe is the structure. But now with the spectrophotometer, can we, we see how these materials behave under light. So this is quite interesting system again, like the one I'm showing you. This molecule, depending upon the pH, it changes its color. So again, here I have compared the modeling data with experiments. So this dye molecule, oxazolyl naphthalene, which is a pH indicator dye, can show different color. Okay, it absorbs in the when it is protonated or in the low pH condition, it absorbs in the 425 nanometer. But then in the basic condition, then it absorbs in the wavelength something like 350 nanometer something. So that's in the modeling also. This is what we get. So the point I'm trying to say is that even the computer and the software can replace not only neutron scattering neutron scattering machine, but also the spectrophotometer. So we can not only model structure, but we can also model the photophysical properties in a different pH condition. Okay, so this is we are in the pandemic situation, and then but this is not the virus which caused that problem. This is rather different virus, satellite tobacco mosaic virus, and then influenza. So what I'm showing is that even you can model, like why what stabilizes the structure of the virus. You can model that. In addition to that, you can also model how these viruses enter into our human cell. How they hack the human cell, how they enter into the human cell, and then how they deliver the genetic material, and all these things. These processes also can be modeled with the computers these days. So we are in the really beneficial time. So as I said, the in silico modeling, like computational modeling, is quite quick, no doubt in that, and many times it can be reliable and it can be accurate. And then like these need very small resources. Like as an individual, I can do myself, so really I don't need to work with a big group or something. So as an individual, I can do it by myself, and you can also do it by yourself. So that's another advantage when compared to an experimental situation. So that's a good thing. As I said, it also can be quite inexpensive, and then as I said, it is like non-destructive, because here we have only models within our system, so they are not really, they are virtual models, right? So that way, like, it's completely safe and non-destructive. So now I will go into my topic, like as I said, like drug discovery approaches, how we can use computers. And in general, we know that drug discovery is a very time-taking process. It takes like 14 to 15 years. I guess many of you know about this. But then this is the data says, when a pharmaceutical company wants to develop a new drug, it takes quite a lot of time. That's why, still even now we don't have a drug for SARS, I'm talking about the SARS corona due to coronavirus 1. I'm talking about the version which was 10-15 years ago. Then still we don't have medicine for MERS, which also erupted like 2008 sometimes. So of course, we can be positive that we will be coming up with vaccines, drugs for the SARS COVID-19, which is due to SARS coronavirus 2. But then so what I'm talking about is the normal average data. So let us assume that we are quite fortunate that we will come up with the drug for COVID-19 very quickly. But then what I'm talking about is the very normal data, like which is based on average of various databases, like data collected over the years. So drug design takes like 14 to 15 years. It's the same with the tracer or diagnostic agents. It's the same. In addition to that, it takes like quite a lot of amount also. Okay, so it takes individual cannot do, like even individual small organization cannot do this. Like only the gigantic business companies can only do such things, like drug discovery, like big companies like Novo Nordisk, AstraZeneca, Fisher. Only they can do such do such projects because it's really very costly. But then this is like if you ignore the computers. But then nowadays, you can use computers, so you can screen compounds, and then you can collaborate with some people who can do bioassay studies or binding assay studies or titration experiments, colorimetric experiments. Then you can collaborate with them, and then you can come up with active compounds. So this is nowadays quite possible because thanks to the use of computers, now it's quite possible. But otherwise, this was the situation. Like it was a monopoly that only the very big companies can be involved in the drug discovery projects. But now things are changing, and that is what I'm here, to present that good message to you. And this is, one success story. Usually, I told you in the earlier slide that it takes like 10 to 15 years. But then with the use of computers, you can say that the drug for Tamiflu and HIV came like in 8 years, which is like quite a big surprise, and thanks to the computers. So in addition to that, so you can really do such things, like you can develop new drugs for any diseases. It can be infectious, non-infectious, using computers. So, but then there are certain details, but I will not go into that. But you can do that, so that is not a problem. So in general, the big pharma industries, are associated with the larger pollution. They are not sustainable. The currently available big pharma companies, whatever they do, many of the steps are not sustainable, and they are not green. So there is a data saying that they release almost 55% of green gas emissions when compared to the automotive industries. This is a really big surprise even for me that these pharma companies are also contributing to green gas emissions. And then so it is very important that we possibly we need to make this development drug discovery process more sustainable. So basically the drug discovery process involves various steps, right? Like target discovery. Let us say that when in the current COVID-19 case, so what we need to do, first of all, we need to identify potential targets in the virus. Okay, so which then you try to identify compounds which can block these targets, right? So this is the second step, like lead compounds identification. And then in this step, like we may be using like 10,000 compounds, but then so the data says that like to come up with one drug molecule, you may have to screen almost 10,000 compounds. But this is like again average, so we are not sure. Like sometimes it can be even more or less. Okay. So then once you identify lead compounds, then you do verification experiments like bioassay, colorimetry, or CD experiments. Then subject these compounds to the animal studies to see that whether these compounds are not having any side effect toxicity to the animals. Then we take it to the human trials. Okay. So there are so many steps when we are doing a drug development. Various steps are there, like target discovery, then lead compound identification, then confirmatory experiments, then animal studies, then clinical studies on the clinical trials, which you do basically using humans. Okay, so even though not all these steps can be done with computers, but at least a few of them can be done with the computers. For example, target discovery nowadays you can do with computers fully. Like once you have the genomics data, you can identify various potential targets. Then even you can propose the 3D structures for these potential targets. Then you can use like chemical space to identify lead compounds for the potential targets. So even this step also can be done by computers. Also the colorimetry experiments, CD experiments, even titration studies also can be done with the computers. Of course, the animal studies nowadays they call it like lab in chip, something like that, which is like in small chip, they have model for human organs, animal organs. Okay, so even that also nowadays can be done. You really don't need to use animals for doing such studies, but nowadays you can do with lab in chip type tools. So the thing is that you can use computers for drug discovery, and then these few steps definitely computers can be used. So the idea is that when you want to use experiments, let us say that you want to screen 10,000 compounds, you'll be buying all these 10,000 compounds, and then you will screen it with like target protein, so which is quite expensive, also involving a lot of human resources. But then the idea is that if you use computers, you can like identify like top 10-50 compounds, then they take these compounds to the laboratory conditions. Okay, so that way you can cut down the cost, human resources, and the cost related to buying chemicals. So that way you can make the drug discovery quite sustainable. And as I said, now I'm going into the main topic, like the drug discovery. I said like why it's very difficult. The reason is that like even for computers, this problem is very challenging because it is a multivariable optimization problem where we try to optimize, come up with a compound which will have many properties, optimal. Like a drug compound should have the larger binding affinity towards a specific target, and it should have also it should have larger binding specificity for a particular target, and it should not have any off-target binding. Then it should have favorable pharmacokinetic properties, pharmacodynamic properties. So when you want to come up with a drug, you need to find a compound which will fulfill all these properties. So this is a problem why in general the drug discovery project is very challenging, and even for computers it is really a challenging project. Otherwise we could have already come up with the drug molecule for COVID-19. So it is challenging, and we are going to see like why, as I mentioned, that it has to fulfill all these properties, and then these are a little bit touched, and all these properties are again related to free energies. See, when you want to improve a material or something, then you need to know how to compute that property, specific property using a computer, right? So here also, when you want to optimize or find out drug compound, then we need to optimize certain property which is computable. So the same way here, when it is a drug molecule, then basically we are interested in the free energy differences. Okay, so basically we want to optimize these free energy differences of this compound in different environments. So here I'm showing you that the binding affinity is free energy difference of the drug molecule in a target when compared to water. So the same way all these drug-like properties can be written as free energy differences. So the point I'm trying to say is that if we can compute these free energy differences accurately, then we also will be able to calculate these properties. Then we can calculate these properties for various molecules and then rank them according to their drug-like properties. So basically you can calculate these properties for, let us say, like 10,000 molecules, or even 100,000 molecules. Then you identify the best compounds having the optimal properties. Then you take them to the experimental condition. So to the students, what I would like to convey is that when you are interested in modeling, drug-like properties, we are basically interested in computing the free energy differences. So the idea is that if we can compute these free energy differences accurately, then we also will be able to model these properties correctly. At this moment, we have, of course, methods for computing the free energy differences. Let us say, for example, you can calculate binding affinity using different approaches. Like you can use Autotalk, Vina, then Glide. There are many different softwares available for computing this binding affinity. But then the problem is that many times they are not that accurate. Okay, so that is the problem. So even there are methods like MMGBSA, MMBBSA, where you can compute free energy differences in a slightly better way, when compared to the Autotalk or Autotalk Vina. Even then, these methods are also not quite reliable. So this is a problem, so even though we can use computers, but then this, the reliability is a big problem when it comes to drug discovery. This looks like a problem. So at KTH, what we are doing is, we are trying to optimize, or develop methods to compute these drug-like properties in a reliable way. So once we can do that, then you can rank the compounds more reliably. Then you can collaborate with the experimental delays to find drug-like molecules. So as of now, we know all this information. Like as I said, we have chemical space, which is about zinc, Cambridge. So we have access to the chemical space. That means these are all the drug-like molecules or lead compounds. Same way, we know the target space, the protein space also we know. What are the targets we need to, which are relevant for us for a drug discovery. So these also we know. So we know protein space. We also know chemical space. Also, we have the powerful computers these days, which can do up to teraflop. One can do up to 10 power 15 operations per second. So there are computers available these days even to do such heavy computing. So that also fine. But the only problem is then now we don't have good reliable scoring functions. Okay. So once we fix that, then computationally you can screen compounds, and computationally you can design drug compounds. So we have been working on developing such methods to fill this space. Okay. So basically for that we rely on quantum mechanics, also machine learning. But today I will not be talking about machine learning, but little bit I will show few results using the quantum mechanics based screening methods that we have developed. But as I said, quantum mechanical theory, cannot be used. Even Jha also mentioned that quantum mechanics cannot be used for systems with atoms more than 200 or something. So you can use this theory for very small systems. But then here we are dealing with protein ligand. Like I show you here, a ligand which is bound to the fibril. The number of atoms can be 10,000 to 1 million atoms. So definitely this theory is not, you cannot be used. So we need to make some approximations. So that is what I will be talking about to some extent. So the idea is that we want to use the more accurate theory, which is quantum mechanical theory, which is better than classical mechanics. But then the problem is this theory is limited to very small systems. You can use for a system up to 200 atoms. But then we want to really deal with the system with a very large time scale, like protein ligand complexes. How do we go about? So what we can do is you can use something like QM cluster model. So then what you do is you take the ligand and then those residues which are around the ligand only into the QM region and do a calculation, and then calculate the binding affinity of the ligand with the environment residues. And then with that you can rank the ligands. Okay, so that is one option. This is called the QM cluster model. And another option is that you can use something like QM fragmentation scheme. So you can fragment the whole protein into individual amino acids. Then you can calculate the interaction between each amino acid and the ligand, and then add these contributions over all amino acids, and then you can get the total interaction between the protein and the ligand. Okay, so this is called the QM fragmentation scheme. So there is another one called QMMM method. I will not be talking about. So these are the different methods available for calculating the binding free energies. where we employ quantum mechanics theory, and even then, even for dealing with protein ligand-like systems. So of course, this is again a multi-scale approach. How we get the binding free energies. I don't want to go into the details, but then it involves like molecular docking, molecular dynamics, then QM molecular dynamics. Then once we have the configurations, then you can use either QM cluster model or fragmentation scheme to get the binding free energies. So this is how we do the calculations. So I will just give like 1-2 examples, because I think we are running out of time. I also have another meeting. So what I'm showing is that how different methods perform when compared to QM cluster model for the specific system, like stearyl benzoylate derivative when it is bound to fibril. So what we show here is that when you use we have used docking, MMG-BACA, MMB-BACA, and then QM cluster model. You can see that, and then we have the experimental binding affinity data. So what you see here is that the QM cluster model is performing quite nicely when compared to other methods, which are like which are traditionally used by all the groups in the world. Okay, so this is some important contribution to the binding free energy calculation that we have developed. And then another method is that, as I said, like QM fragmentation scheme. And this here I just show you one example, one results. The particular ligand FDDNP, it is supposed to be binding strongly to the tau fibrils than amyloid fibrils. Maybe if you don't know what these are, just listen to me, and then later on you check. So these are all the fibrils which are accumulated in the human brain, having neurodegenerative diseases like Alzheimer's disease. So the interest is that we want to identify this accumulation of these fibrils in the brain using same like PET technique or something, like it's the same way like John mentioned. You inject these compounds into the blood, then they go and bind to the fibrils in the brain. Then once you do the PET scan, you'll be able to identify whether the fibrils are accumulated in the human brain or not. Okay, so but the idea is that when currently we cannot distinguish between accumulation of tau fibril or amyloid fibril, because the compounds can bind to these fibrils with the same binding affinity. So we want to optimize the binding specificity of the compounds. So here with the computational modeling tool, we try to understand like why FDDNP having binding specificity for tau fibril than amyloid fibril. But if we use the traditional methods like MMG-BACA, then rather we are getting incorrect results. But then with the use of our QM fragmentation scheme, we are able to get the correct trend that why FDDNP is binding to tau fibril strongly than the amyloid fibril. So as I said, using computational modeling tools, you can really understand that the PET tracers, how they go and bind to the brain, and even you can explain, the binding assay data coming from the in vivo experiments. So here I show you that in the tau fibril, these compounds, how many different binding sites are there, and why do they prefer certain sites than the other one. So such things can be modeled with the computers. Okay. So I will just show you like few more examples, and then I will close my topic. So this particular probe CQ, it is based on the experiments. You can see that it is binding strongly to amyloid beta fibril than other fibrils like tau fibril or monomer of amyloid beta or amylin fibril or synuclein fibril. And then with the modeling, we are able to explain why this particular probe binds strongly to amyloid beta fibril. And this is also inconsistent with the experiments. So we saw that with this amyloid beta fibril, the binding free energies are quite lower, like in the range -14 to -28. But when it comes to other fibrils, it was in the range of like -4 kilocalories per mole. So we are able to explain the binding specificity of this probe towards the amyloid beta fibril when compared to amylin or synuclein. In addition to that, you can also model the off-target interaction of tracers with specific targets. So the tau tracers, they also bind to the mononuclease B which is not really a nice feature. So we want to understand the tau tracer only should bind to tau fibril, but then in the human brain they also go and bind to the monoaminoxidase DSB, giving a wrong diagnostic signal. Okay, so we want to avoid that tau tracers binding to monoaminoxidase DSB. So what here we have done is that we have checked all the tau tracers, and then how do they bind to, whether they also bind to the monoaminoxidase DSB. And then our results showed that yes, it is true that tau tracers also bind to monoaminoxidase DSB, which is an off target in this case. But then when we also figured out that certain second generation tau tracers, they have least binding to monoaminoxidase DSB. So when you want to use tau tracers for tau imaging, then it's good to go for second generation tau tracers instead of the first generation tau tracer, because they also have binding affinity towards the monoaminoxidase DSB. So that is an important outcome that come from the modeling. Then let me just show one more slide, and then I will complete my talk. So what we found is that we know that certain probes bind to amyloid fibril, but then here we saw that it not only binds to one single site, but then it can bind to multiple binding sites. In addition to that, photophysical property can be site dependent. Like as we have shown here, only in site 4 it shows the experimentally shown red shift, but in other sites it shows blue shift. So this way, you can also understand the experimental data. You can interpret the experimental data with the use of computational modeling. So overall, this is the research summary. This is what I do. I do method development for computing binding affinity properties, photophysical properties. Then when it comes to applications, then I study various tracers, optical diagnostic agents, because that insight will give us to design better compounds, right? So this is why I'm doing this application. Then in addition to that, some basic work, and these are my other domains of research, like color modeling and molecular probes or biomedical imaging applications. So with that slide, I will conclude my talk, and then if you have any questions, you can ask. And I again thank all the organizers for giving me a chance. And it came in very short notice. I got this call on Sunday. Otherwise, I could have prepared the slides in a much more organized way. Sorry for that. But in case in future, if there is a chance, we can again speak. Okay. Thank you very much.
Thanks a lot, sir. Very inspiring, wonderful, superb, excellent, tremendous lecture delivered by you. You have given time from your busy schedule. So we thanks from our university family and thanks you wholeheartedly. And we feel we have invited to our next program also. And we will again call you and we will contact you for deliver next lecture in our next international program. And we welcome you. And we are so much thankful to you, sir.
Anand sir, am I audible?
Yes.
Yeah,
1 minute.
Sir, I want to ask one little small question, sir.
Yes.
Thank you very much, sir, for this wonderful talk. And I learned a lot with this virtual application of this modeling in field of drug discovery. I will wonder to know your opinion about one particular thing. What you were showing that virtual screening of molecule, whether the molecule is binding with the active sites in the target, we can find it on the computer. So what is your opinion on the point of view that when one medicine or some molecule is ingested in the body does not contain only a single receptor or single binding site. It has too many. So, but in the computer we have only one target. So molecule is binding only one target, but inside the body, molecule is binding is infinite number of targets. So there cannot be some difference.
Yeah, you have asked a very important question. In models, we always do a simplified version of the whole real process. But of course, even So what you are exactly asking is the toxicity, like side effect. For example, I a little bit presented about the off-target binding. The compounds, what we design, they are supposed to go and bind to a specific target, but in reality, it is not like that, because we have like so many targets, enzymes, as I said, even in brain itself, there are like 200, 300, target proteins, enzymes. So what we need to do is, so we also have to do the off-target modeling. So whether these compounds are also binding to the off-targets. So we need to test that. So you need to only take those compounds which are having the least off-target binding. Okay. So this is additional overload, but do this computationally. Yeah, sure. Thanks for the question.
Thanks a lot, sir. Once again, you are most welcome. And we are inviting you for our next program also. You are such a dynamic professor abroad in Stockholm University, Sweden. We are so much thankful to you once again, sir.
Thank you.
Now our next speaker is Dr. Deepak Tripathi, Head Department of Chemistry, MK College, Darbhanga. I will shortly introduce him. He did his MSc in 2018 from Lucknow University, India. He did his PhD from GNU, New Delhi, CDRI, Lucknow. He joined as Trainee Research Associate 2008. He joined as Senior Research Associate 2012 to 2015. He did his postdoctoral fellow, CIFRA postdoctoral fellow in 2015 to 2017, LLCC CNRS Toulouse, France. And again, he joined as assistant professor in Department of Chemistry as a head in MK College, Darbhanga. He has done a teacher training research associate, Jubilant Chemist, Noida. He has total 29 publications and more. He has more than 5 patents. He has awarded Best Award, Presentation Award by Mahatma Gandhi Central University, Motihari. He got Young Scientist Award by Lucknow Christian College in year 2018. He did CIFRA postdoctoral fellowship by DST Government of India. He has CDRI Incentive Award by CDRI Lucknow in 2011. He is also a professional life member of Association of Carbohydrate Chemists and Technologists of India. He is also a life member of Association of Chemistry Teacher Mumbai. He is very wonderful, excellent, dynamic professor and head in MK College Darbhanga in Bihar. I request Professor V.D. Tripathi sir to deliver his lecture. Kindly sir, please.
Thank you very much, sir. Thank you very much for your nice introduction. In fact, it was very vast. And I will start my presentation, and I will share my screen here. So, if there will be some problem, please unmute and confirm me. So, my screen is visible?
Yes, sir. Your screen is visible, sir.
Thank you very much, sir. So, I will give a short lecture, and briefly I will explain the concept of sustainability, and later I will move to how this sustainable or greener approach can be applied in field of chemistry for synthesis of molecules of great importance. So first, I will start with a line which I heard too many times when we have some environmental lecture or classes, or even starting from school in a very beginning, that save the nature, save the nature. So my question at that point is, do we have the capacity to save the nature, or we are in a process to compete with the nature? My answer is no. We are too small, or we are nothing in comparison to nature. So if we believe that we are saving the nature, it means that we are at some point that we cannot understand or judge something. Actually, nature is saving us, and we have to work with the nature. So once we will live or we will work with the nature, then in some way we are with the nature or we are saying the nature. You can imagine or suppose once God has created the earth, or earth was created, and slowly life was beginning. But when one the creature that human beings comes on the earth, then what started to happening? And now the situation is become so tedious that we have to think for saving the nature or to develop some way like sustainable or greener approach for the nature. So it means that at somewhere we are going away from the nature. And unless and until we have not fulfilled the gap, we cannot revert back or we cannot save whatever we want to our nature or to earth or environment. So the word sustainable is very closely related here, that not only to in one aspect. Sustainable has too many aspects. I will give an example here. Most of, if you remember or go back certain thousands of years, at one time we were taking waters from the rivers, from the pond, and even drinking water. And when the water was consuming and water level goes down, then we dig the wells and we take water from wells. And when water again goes down, we do the hand pipe or something, then again goes down, we dig the submersible pump, tube well pump, and now again water level is going down and down and down continuously. So it means that we are developing, we have too many tools, we are advanced, we can make machines which can bring water from anywhere in the earth. But this is not sustainable. At some point, at some day, again water level will go down and the groundwater will end up, our life will be in danger. So it means that at one place we are making development to fulfill our need or greed, whatever, but at some other hand, we are going against the nature. So in my opinion or in my way, sustainability is just living the life with the nature, how the nature has made the life. Then only we can feel the concept of sustainable. Here are some lines that Organization for Economic Cooperation and Development defines the sustainable chemistry, a scientific concept that seeks to improve the efficiency with which natural resources are used. So this word, the natural resources, have very large impact in the sustainable world. How we are utilizing the natural resources in any way. I given the example of water. There is air, there is many things, trees. So once we are developing technologically, then we have the power to make a war with the nature in very fast manner, that we have the tool which can cut a big tree in not more than 2 seconds. So at some place we improve, but that is not sustainable. We are moving very far from the sustainable development. So sustainable chemistry is built on 2 concepts. One involves the manufacture and use of chemicals in ways that manage the substance risk. And the second is the innovation in chemistry that help the world towards sustainable goals in such a way as reducing the greenhouse gases emission, alleviating hunger, or I was reading one research, and you will not believe, you will be surprised that the level of carbon dioxide was maximum on the earth when there was no human being on the earth. So you can imagine that it is not only human being which is contributing towards the rising of carbon dioxide level. So again, there are 2 terms come, the green chemistry and the sustainable chemistry. More or less, people consider both are same, but there are a little difference between them. Actually, the sustainable chemistry is an industrial process that creates the better products and results in fewer pollutants and save the natural resources. But green chemistry is doing something innovative which makes the chemistry environment friendly, or it deals with the fundamental aspect of chemistry without regard of industrial process and profitability. Either way around, over time it will become more and more necessary. Like in one lecture we see that use of ionic liquids. Use of ionic liquid for chemical synthesis is very good way, but the problem associated with the ionic liquids is the scale-up process, and itself the byproduct of ionic liquids are very toxic. So okay, just you see three pictures. I hope most of you recognize these three pictures. They are very renowned persons, like Frederick Holler for urea, and Woodward, everyone know his contribution in the chemistry, and this Hoffman. These are very famous icons in chemistry. But you think that if these persons were in today's scenario in the chemistry field, whether they would be as comfortable as they were at that time? In my opinion, no. Because in today's time, there is a lot of pressure on the chemist or synthetic chemist, organic chemist, whatever, to develop a process which is sustainable, which is green, which is environment friendly. So the things or the challenges against the chemist is changed. That which was against the Holler, not right now. Even priorities and perspective and challenges all are changed. So it means that we are again going away from the nature, and we will, and the time has come when we have to think, not only think but act, to do something to save ourselves, to save our life. Again, you see, this is a picture of synthetic chemist who is working in laboratory and organic chemist in industry, and both of them are under heavy pressure. What are you using, what chemical using, and what byproducts of forming in the reaction? Because before synthesizing something new, doing something new, we have the pressure that whether we are not polluting the environment. So the focus has changed from innovative to sustainable chemistry, and this sustainable will save the life on the earth. There are several aspects which we can, as a chemist, what we can do. So as a chemist, there are several aspects we can pick in the synthetic chemistry. That first one is a solvent, because solvent has the very big role in the chemistry. I don't know whether any of you know or not, in chemical or pharma industry, for synthesizing 1 kilogram of medicine, or in technical terms you say API, active pharmaceutical ingredients, industries are making 1,000 kilogram of waste. And this is the only reason why only India and China are manufacturer for all the world, because no developed country want to keep the waste in their country. So someday the day will come when the country will fill with the waste of APIs. It can be more than 1,000. So imagine, for 1 kilogram of API, we are producing 1,000 kilogram of waste. So this 1,000 kilogram of waste is nothing but the solvent which you use to isolate the molecule. There are many organic reactions, and particularly the carbon-carbon bond formation, that are accelerated in water relative to the organic solvents. So it depends on the reaction or the mechanistic pathway that which kind of solvent is going to facilitate the reaction. So if we can frame, or we can think some chemistry which utilize the process which use the green solvent like water, and this will contribute towards the sustainable development in chemistry. We will have to frame the reaction protocol, how we are synthesizing the product, we have to think in different way. The most important class of organic compounds in terms of produced are carbohydrates, as they are represent the 75% of renewable biomass. So the chemistry involving or inspired from the carbohydrates will be very beneficial. We have to think about some change in the catalyst, because most of the metal catalysts are very toxic. When the byproduct goes in the drain and rivers, they make the toxicity the irreversible multi-component reaction to save the atom economy. Atom economy has already explained by sir in previous session. So now I will come on some process which I did in my laboratory in the field of development of some green synthesis protocols. In one of the reaction, we synthesize the spirophenazolene derivatives, and the reaction medium is solvent is nothing but water. Reaction is at room temperature, and the catalyst is again the carbohydrate, the sugar. So, and this phenazolene derivative or nucleus has a very crucial role in drug development, because most of them are very active, biologically active compounds, and they represent the frontline class of many drugs. So if you see this, to exploit the catalytic efficiency of this beta cyclodextrin, we changed some reactant, then again we were able to utilize the cyclodextrin as catalyst for synthesis of these quinazolene derivatives. Several analogs were prepared. Now I will explain how these reactions are catalyzing these very decorative and good looking molecules are cyclodextrin. See how in very decorative manner how the sugar molecules are joined. Cyclodextrin are not natural molecules, they are synthetic, but they consist of only sugar or carbohydrate molecules which are biodegradable and not harmful for ecosystem or environment. So it has three forms, alpha, beta and gamma, and one has the 6, 7 and 8 sugar molecule. I will use the beta cyclodextrin as a catalyst. See how the reaction is going on. Actually, this is inner cavity, as you can see here, it has some hydrophobic inner cavity and hydrophilic surface, because at the surface you have the OH, hydroxy functions. So you see, if there is a hydroxy function, so hydrophobic part of the molecule insert inside the cavity, and this induces the catalytic efficiency of the cyclodextrin. This isotopic anhydride molecule gets trapped inside the cavity, and once it's bound for the joined with the hydroxyl group by hydrogen bonding, it activates the isotopic anhydride molecule, and then these amines react, and then after decarboxylation we get the desired product. So in this one more example I will show, which we did. This is a tryptanthrene molecule. This is natural molecule, this is alkaloid, and it has a very vast application in drug discovery programs because it has a antimicrobial property and many more, but it used for antimicrobial properties. The one limitation with the molecule that it has some toxicity and has a lower solubility in aqueous solvents like water. So how this molecule, this was the first synthesis we have reported of the tryptanthrene in some eco-friendly manner. This is very simple reaction using the beta cyclodextrin and water as a solvent at room temperature. We use isotopic anhydride and isotin derivatives. Simply we mix in water, but a rotation per minute of the magnetic stirrer should be very high, which I feel that is the crucial part of this synthesis. And we were able to synthesize the several derivatives of tryptanthrene, and this work was highly appreciated. For this particular work, CDRI has awarded in my PhD. So how this reaction goes on, you can see here it contains some hydrophobic cavity inside, and once the molecule will bind here, see the other molecule we trap, and then it activates both the reactants to form the product. How the decarboxylation occurs, and after decarboxylation, molecule again cyclizes to form the tryptanthrene. So we also used sugar molecules to attach, to join with the tryptanthrene molecules. You see, we picked some sugar libraries here from glucose, galactose, xylose, and also beta cyclodextrin. We prepare the azide library, and then we perform the click chemistry with the tryptanthrene molecule. And in this way, this tryptanthrene molecule, which we synthesized via green protocol, were again via a sustainable chemistry joined with the sugar molecule, and we get some tryptanthrene molecule attached with the sugar. And these compounds were very new, and they were having a very nice application in anti-tubercular drug discovery, because they were very nicely inhibiting one protein kinases of Mycobacterium. And as you know, the protein kinases are very crucial for life cycle of Mycobacteria. So in this way, we were able to find out some leads that has inhibited the protein kinases of Mycobacterium in more than the known compound for inhibition of protein kinases that is available in market, and it has only 12%, but the compounds were showing good. And because of attachment of these sugar molecules, they were having the bioavailability of these molecules were enhanced. Again, in a separate work, what we did, we prepared some hexahydrospiro-inulin derivatives. We developed both the three protocols under microwave, under ultrasound, and room temperature, and we compared all these protocols. We find that the reactions under microwave conditions were very fast, and there in this reaction there was also a great deal of selectivity because these reactions were regioselective. And the reason for regioselective was later find out that it is the secondary orbital interaction that is present in one of the transition state but absent in other transition state. So preferentially the product formed via the favorable transition state, and probably this is the reason behind the regioselectivity. Most of 24 compounds have been synthesized for this and characterized. So with this argument, what I want to conclude that we are highly indebted to our mother nature and environment, due to which our existence is possible. And if we are doing something which is against the nature, that in some way we are making a question mark on our existence. So it is our moral and social responsibility to protect them, and the chemists have a long way to go before they meet and satisfy the need of environment, economy, and society. So I will acknowledge the support from TP College to give me opportunity to present my work here. I will acknowledge my university, BNMU, and my college, MK College, to offer me a post to work there. I will acknowledge my collaborators, Professor Kishore Srivastava, Dr. Sarj Mignani, and Dr. Samir Tiwari for experimental work and biological work. And I am thankful for CSIR CDRI for providing the necessary support in the research, and also CEFIPRA for funding. Thank you very much, and I will be happy to answer any question if you have. Thank you.
Thanks a lot, sir. You have given time from your busy schedule. We thanks you wholeheartedly. From our university also, we thanks you wholeheartedly. Very nice, inspiring, wonderful, excellent lecture delivered by you. We are so much thankful to you once again. We feel proud of you from your busy schedule. I know you have the meeting from 3:30 p.m. Then also you have given us opportunity and time to deliver your lecture from your busy schedule. We are so much thankful to you. Thanks a lot, sir. Now our next speaker, as well as keynote speaker and the chairman of this technical session, is Dr. Naresh Kumar, Professor, University Department of Chemistry, BN Mandal University, Madhepura. I will introduce him very shortly. He did his graduation in 1983 from L.N. Mithila University, Darbhanga. He did his post-graduation as inorganic chemistry as a specialization in 1985 from L.N. Mithila University, Darbhanga. He did his doctorate in organometallic compound in 1996, L.N. Mithila University, Darbhanga. He has been appointed as assistant professor in Department of Chemistry, BNMU, Madhepura on 5/11/1996. He has been promoted to the rank of associate professor on 5/11/2018. He has promoted to the rank of university professor on 5/11/2013. He has published 35 papers in national and international journal. He published one book. He delivered 10 lectures. He has organized 3 seminars as an organizing secretary. He has participated in more than 30 national and international seminars. He has research interest in designing new functional multidentate phosphorus and nitrogen-based ligand organophosphorus compound and the transition metal organometallic chemistry. He is also designing new type of water soluble selenium and phosphine ligand for medicinal and catalytic study. Next, macrocyclic ligand and their transition metal chemistry, inorganic material of polymers, studies of phosphine bound organometallics, environmental chemistry and spectroscopy. He is also the member of many professional body, member board of syllabus, member cable vigilance committee, NSS program officer, BNMU campus, member advisory committee, BTSP TP College Madhepura, director simulation center, vocational and professional examination controller, Department of Chemistry, BNMU Madhepura, routine in charge, Department of Chemistry, center superintendent, BCA, BTech and PG exam performed responsibility of university. He is also acting as nodal officer, RUSA Department of Chemistry, BN Mandal University, Madhepura. He is co-convener, promotion cell, BNMU Madhepura. He is honorable member of Senate, BNMU Madhepura. He is also general secretary, BN Musta Madhepura. He is general secretary, BN Musta, Council of Chemical Science. He is professor in charge, University Department of Education. I request Honorable Chairman Sir and keynote speaker of this technical session, Professor Dr. Naresh Kumar Sir, to deliver his lecture. Kindly, sir, please.
Thank you, Anand Mohanji, for inviting me. Good morning. I am Naresh Kumar, Professor of Chemistry, BN Mandal University, Madhepura. First of all, I would like to thank organizer Darshan Parishad Bihar and TP College Madhepura for inviting me to this landmark international webinar. Respected Honourable Vice Chancellor, BN Mandal University Madhepura, who is also chief patron of this webinar, Professor Gyananjay Dewvedi sir, and Principal TP College Madhepura, as well as patron of this webinar, Professor KP Yadav sir. Important speaker of this webinar, Dr. Kasinath Durke, Associate Professor, Department of Chemistry and IT, Warangal. Dr. Prakash Chandra Jha, Dean of School of Applied Material Science, Central University, Gujarat. Dr. Vidit Tripathi, Head Department of Chemistry, MK College, Darbhanga. Dr. BN Arul Murugan, Associate Professor, KTH, Royal Institute of Technology, Stockholm, Sweden. Dr. Syamal Kishore, Chairperson of this webinar and General Secretary, Darshan Parishad, Bihar. Dr. Sudhanshu Sekhar, convener of this webinar, who is also PRO and DR Academic, Gyananjay University, Madhepura. Dr. Anand Mohan Jha, Organize Secretary of this webinar and Assistant Professor, BNMU University, Madhepura. Today, I am going to share keynote speech about sustainable chemistry for the future. I think we all agree that it is a time for change, and this is why we sit here and talk here at this landmark webinar. We know that chemistry is key determinant of science. It is a key determinant of health, food, energy, education, and a condition to an adequate standard of living as well as non-living material. It is a key for all sustainable development goal and must be now recognized and treated as such. Our life is supported and enriched by an enormous variety of chemical products that have been invented by chemists and chemical engineers and produced by chemical industry and laboratories. But at the same time, we have learned from the experience of past decades, countries are faced with environmental concerns, including the unsustainable use of non-renewable natural resources, the degradation of ecosystem, and disruption of the environmental system that support human life. The general public now expect university teachers, chemists, and chemical engineers to work to minimize and reduce adverse effect on human health and the environment associated with the production and use of chemical products. Sustainable development is one of the most frequently used terms in today's political debate. Our current understanding of sustainable development is a regulatory idea. It has been defined sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. As a consequence, all our individual and political actions should be reflected in the light of their societal, economical, and ecological sustainability. This challenge concerns every field of society, among them particularly chemistry and chemistry education. Both fields should reflect on how chemistry and chemistry education can contribute to more sustainability in our society today and in the future. For this reason, chemists and chemical engineers as well as chemistry teachers have a great influence on and thus bear a responsibility for protecting the global environment. To this end, new concept or approach, chemical technology is needed. Sustainable chemistry is a relatively new concept and scientific area that aims to improve the efficiency with which natural resources are used to meet human needs for chemical products and services. In doing so, it can contribute to achieving a cleaner, healthier, and sustainable environment, and improving the image of chemistry as a problem-solving science in society. In modern era, teachers, chemists, scientists, industries frequently use new chemistry like green chemistry as well as sustainable chemistry. But there is minor difference. Green chemistry has a longer history, which principles established in 1990. According to the US Environmental Protection Agency, green chemistry is the design of chemical products and processes that reduce or eliminate the generation of hazardous substances. The term sustainable chemistry has been introduced more recently in 2004. Sustainable chemistry seeks to improve the efficiency with which natural resources are used to meet human needs for chemical products and services. Sustainable chemistry encompasses the designing, manufacture and use of efficient, effective, safe, and more environmentally healthy chemical products and processes. Sustainable chemistry stimulates innovation across all sectors to design and drug discovery, new chemicals, multifunctional compounds, production processes, and product practices that will provide increased performance and increased value while reaching the goals of protecting and enhancing human health and the environment. Sustainable chemistry can ensure optimum efficiency in everything we do, both individually and as a society. Sustainable chemistry also means protecting and extending employment, expertise, and quality of life. One of chemistry contributes to meeting the challenge of more sustainability in the development of our society is the promotion of sustainable chemistry in research and industrial production. Under the name of green chemistry or sustainable chemistry, a lot of effort has been undertaken to make future chemistry less poisonous and less hazardous. Green chemistry aims at making chemistry more energy efficient, at reducing waste disposal, and producing innovative products with less consumption of natural resources. Alternative processes and reaction pathways are designed. New materials and products are developed, contributing to meet our needs today, but with taking more care of interest of future generations. Modern chemistry education is challenged by both the political aim of sustainable development of our society in general, as well from the call of green chemistry strategy in chemical research and industry in particular. School chemistry education should promote competency of the young generation to become scientifically literate. This means chemistry education has to contribute to making a student capable of actively participating in society. Competency need to promote to allow a student to understand and participate in societal debate about application of chemistry and technology. One prerequisite is that a student should achieve substantial chemistry knowledge in the context of respective sustainability issues to understand the underlying developments, alternatives, and dilemma. But subject matter knowledge will not be enough. The student as future citizen also needs to learn how societal debate about questions related to chemistry, industry, and the environment functions, as well as development skills to involve themselves together with others in societal process of democratic decision making. But this is only one side of the coin. Society can only decide about about the alternatives of raising sustainability in chemistry, related development and business. If there are any chemistry teachers, future chemists and chemical engineers need to learn what a more resource efficient, environmentally friendly chemistry for the future might look alike. That means the area of green chemistry, sustainable chemistry should become part of their training from the very part. Students of chemistry program at universities should be guided to develop a deep consciousness of the importance and sustainability especially in chemistry, research and industry, and also to develop knowledge and a skill to operate them. Fields of study are using environmental issues as the context of the chemistry education, using the debate about plastics as socio-scientific issue for chemistry education, or making the analysis of the environmental impact of chemical synthesis a part of organic chemistry course in upper secondary school. Another set of papers will be reflect the role of sustainability, usage and green chemistry or sustainable chemistry in higher education. These papers focus on both changing the curriculum towards the embedding explicit lesson on sustainable development in higher chemistry and chemical engineering education, but also on how to put the principle of green chemistry into practice in higher chemistry teaching. The later stage can be achieved. For example, by incorporating alternative reagent or making technical problem from the sustainable debate a context of higher chemistry learning. By the United Nations World Decade of Education for Sustainable, which ended 2014, the ground for broader application to be prepared. Anyhow, working on sustainable future is an ongoing process. Concerning this, we hope that this theme issue will inform the discussion and will help to strengthen and motivate chemistry education's contribution to more sustainable future. Sustainable chemistry provides a robust framework bringing together research, development and innovation sectors from academia. Sustainable chemistry inspires a change of pace and a new mindset that society needs in order to become more sustainable, smart and inclusive. But sustainable chemistry is important. Sustainability for the future. Sustainable chemistry has huge part to play in solving society's current and future challenges. Innovation from chemical sector will be essential to sustainable low carbon economy. Sustainable chemistry also has challenges to protect and extend employment, expertise and quality of life. Innovation to need to stimulate a competitive knowledge. Sustainable chemistry must be problem shooter and acceptable to the society. We have to prepare good drugs, which is not environmentally and sound and economically viable, which can sustain very well both living and non-living things. Sustainable chemistry to solve global challenges. We have to select best and non-hazardous solvent, which maximum product in chemistry and chemical industry. Now, being a chairman of this webinar, I would like to thank important speaker, Dr. Gurte, for providing his perspective from organic chemistry point of view and suggesting the change in status quo on unsustainable practices in chemical industry to a practical and sustainable alternative. I also thanks to Dr. P.C. Jha for preparing great new methods to use in laboratory which are sustainable instead of current practices and providing the empirical evidences for the same. Very nice lecture given by Dr. P.C. Jha. My new speaker, Dr. Murugan Sahab, his lecture was very nice and all the way from Sweden and talking to us about the modern computational alternatives during preliminary lab work, which of course is more accurate and eliminate of potential human error, which is unavoidable even with our best effort. All speakers given very nice lecture and it is a symbol of success of this webinar. Now, lastly, a lot of thanks again to all dignitaries and our important speakers. Thank you again. Thank you.
बहुत बहुत धन्यवाद सर। आपका व्याख्यान बहुत ही उत्कृष्ट, प्रेरणादायक एवं ज्ञानवर्धक रहा। यह विश्वविद्यालय परिवार के लिए गौरव की बात है। आपने अपना महत्वपूर्ण समय इतना व्यस्तम शेड्यूल से निकालते हुए हम लोगों को दिया। आप बहुत सारे कमेटी के भी मेंबर हैं और बहुत सारे मीटिंग में भी आपको जाना रहता है, फिर भी इतना महत्वपूर्ण समय निकालते हुए आज आपने मुख्य वक्ता के रूप में और टेक्निकल सेशन की अध्यक्षता के रूप में अपना दोनों व्याख्यान दिया। इसके लिए बहुत बहुत धन्यवाद। विश्वविद्यालय परिवार की ओर से हम आपको तहे दिल से शुक्रिया अदा करते हैं। ऐसे विद्वज्जन को हम लोगों को आप पे गर्व महसूस करते हैं। आपका बहुत बहुत धन्यवाद। प्रणाम। अब हम कार्यक्रम की कड़ी में आगे बढ़ते हुए आज के चेयरपर्सन प्रोफेसर डॉक्टर श्यामल किशोर सर, जो हमारे जनरल सेक्रेटरी हैं दर्शन परिषद के, उनसे अनुरोध करते हैं, उनसे निवेदन करते हैं कि वो आज का अपना व्याख्यान दे। उनको प्रणाम करते हैं, नमन करते हैं, अभिनंदन करते हैं। प्रोफेसर डॉक्टर श्यामल किशोर सर, जनरल सेक्रेटरी दर्शन परिषद बिहार, you are requested to deliver your lecture. Kindly sir.
धन्यवाद आनंद मोहन जी। आज मुझे इस बात की प्रसन्नता हो रही है कि बिहार दर्शन परिषद और पीपी कॉलेज मधेपुरा के दर्शन शास्त्र विभाग के संयुक्त तत्वावधान में अंतर्राष्ट्रीय वेबिनार का आयोजन किया जा रहा है। और मुझे तो लगता है कि दर्शन के विषय में लोगों की सोच जिस रूप में बदल रहा है मधेपुरा में, आने वाले दिनों में दर्शन जो कहीं न कहीं हाशिए पर चला गया था, आज लोग इसके प्रति सकारात्मक सोच के साथ जुड़ भी रहे हैं। आज कई वक्ता थे जिन्हें मैं सुन नहीं पाया क्योंकि मैं महाविद्यालय के किसी आवश्यक कार्य में संलग्न था। सर्वप्रथम मैं धन्यवाद देता हूँ विश्वविद्यालय के दार्शनिक कुलपति प्रोफेसर ज्ञानंजय द्विवेदी जी को और साथ ही महाविद्यालय के प्रधानाचार्य प्रोफेसर के.पी. यादव जी को, BN ओझा दर्शन परिषद बिहार के अध्यक्ष को, साथ ही कई वक्ता जो कि हम नाम देख रहे हैं, डॉक्टर काशीनाथ धुरके NIT वारंगल, डॉक्टर प्रकाश झा, डॉक्टर GT त्रिपाठी, डॉक्टर मुरुगन और आज के इस कार्यक्रम के आयोजक सचिव आनंद मोहन झा जी और कन्वीनर सुधांशु शेखर जी। मैं तो दर्शन का विद्यार्थी हूँ और मुझे यह दायित्व आप लोगों ने दिया है, उसके लिए मैं आप सबों के प्रति आभार व्यक्त करता हूँ। दर्शन के विषय में कहा जाता है कि फिलॉसफी इज द मदर ऑफ ऑल सब्जेक्ट। निसंदेह सभी विषय का कोई न कोई दार्शनिक पक्ष होता है। आज का जो विषय का चयन किया गया है, सस्टेनेबल केमिस्ट्री फॉर द फ्यूचर, यह निश्चित रूप से फिलॉसफी ऑफ केमिस्ट्री है। जिस विषय की चर्चा हुई है वह निश्चित रूप से दर्शन के व्यवहारिक आयाम के अंतर्गत आता है। दर्शन का व्यवहारिक आयाम वर्तमान सभी उन चुनौतियों के विषय में विचार करता है जिसकी जरूरत है आज समाज को इसमें सुधार करने की। हम जानते हैं कि आज सभ्यता के तीसरे दौर से गुजर रहे हैं, जिसे हम ज्ञान सभ्यता कहते हैं। आज की सभ्यता की जो धुरी है वह है तकनीकी और ज्ञान, लेकिन तकनीकी और ज्ञान की सभ्यता में भी कई प्रकार के खामियों से संपूर्ण समाज प्रभावित हो रहा है। इसीलिए अल्विन टाफलर जो अमेरिकन थिंकर हैं, उन्होंने इसे थर्ड वेव कहा था और इनकी एक बहुत ही महत्वपूर्ण पुस्तक है फ्यूचर शॉक, भविष्य के झटके। निश्चित रूप से कहीं न कहीं हमें आगाह कर रहा है कि हमें किस प्रकार की जीवन शैली को अपनाना चाहिए। आज का जो विषय है वह निश्चित रूप से प्रासंगिक है। सारी दुनिया के रसायन विज्ञानी पर्यावरण हितैषी रसायनों की खोज में संलग्न हैं। रसायनों द्वारा मानव समुदाय एवं पर्यावरण पर पड़ने वाले दुष्प्रभाव को देखते हुए यह आवश्यक हो गया है कि रसायन विज्ञान जहां तक संभव हो अधिक सौम्य हो। इसी उद्देश्य को ध्यान में रखकर हरित रसायन विज्ञान की कल्पना की गई है। हरित रसायन, जिसकी चर्चा काफी अन्य वक्ताओं के द्वारा किया गया होगा, रासायनिक उत्पादों और प्रक्रियाओं का वह रूप है जो खतरनाक पदार्थों के उपयोग एवं उत्पादक को कम करता है। मूल रूप से हरित रसायन विज्ञान ऐसे पर्यावरणीय सौम्य रसायनों की उत्पादकता विधि है जो न केवल पर्यावरणीय दृष्टि से अपितु कार्य क्षमता तथा आर्थिक रूप से भी श्रेष्ठ हो। ग्रीन केमिस्ट्री नेटवर्क द्वारा भारत में हरित रसायन विज्ञान के सिद्धांतों को प्रयोगशालाओं, कक्षाओं से लेकर उद्योगों तक में स्थापित करने की दिशा में प्रयास किया जा रहा है। भविष्य की सबसे सफल रासायनिक कंपनियों वे ही होंगे जो अपने प्रतिस्पर्धी लाभ के अवसरों का उपयोग कर सकेंगे। आज जरूरत यह है कि पाठ्यक्रम में इसको लागू किया जाए कि कहीं न कहीं जिस रूप में रसायन का प्रयोग वर्तमान समय में हो रहा है वह कहीं न कहीं हम सबों के लिए एक खतरा की घंटी भी है। ऐसी स्थिति में बुद्धिजीवियों का कार्य है कि हम उसे किसी न किसी रूप में जो रसायन का जो सस्टेनेबल पक्ष है उसको हम लोग आत्मसात करें, तभी हम सुंदर भविष्य की कल्पना कर सकते हैं। रसायन का प्रयोग आज से नहीं हो रहा है। यदि सभ्यता के प्रथम रूप को देखें तो वहां सभ्यता का जो रूप था वह कृषि पर आधारित था। इन दिनों रसायन का प्रयोग इस रूप में नहीं हो रहा था, लेकिन आधुनिक समय में जिस रूप में रसायन का प्रयोग हो रहा है उससे स्वास्थ्य और साथ साथ पर्यावरण भी दूषित हो रहा है। इसीलिए आज जीवन को जरूरत है कि हम स्वस्थ जीवन कैसे जी सके। इसीलिए सम्यक आहार, सम्यक विहार और प्राकृतिक उपचार आज के जीवन शैली का हिस्सा होना चाहिए। इसलिए आज किसी न किसी रूप में हमें यह सोचना होगा कि हम किस प्रकार के रसायन का प्रयोग करें ताकि वह टिकाऊ हो सके, सस्टेनेबल हो सके। इसलिए मैं आप सभी आयोजकों को मैं बधाई देना चाहूंगा कि आप इतने प्रासंगिक विषय को आज चर्चा का विषय बनाया है और निश्चित रूप से यह चर्चा का विषय से लोगों को लाभ मिलेगा और निश्चित रूप से हम समझते हैं कि इस पर और शोध की जरूरत है और लोगों को जागरूक करने की जरूरत है, तभी हमारा आने वाला फ्यूचर अच्छा हो सकेगा। एक बार मैं पुनः सुधांशु शेखर जी जो इसके कन्वेनर भी हैं और आनंद मोहन झा जी जो ऑर्गेनाइज सेक्रेटरी हैं, जिनके सौजन्य से और महाविद्यालय परिवार के सहयोग से, प्रधानाचार्य के सहयोग से, सभी लोगों के सहयोग से यह सफल कार्यक्रम रहा और निश्चित रूप से यह अंतर्राष्ट्रीय वेबिनार एक अच्छा मैसेज दिया है लोगों को ताकि इस दिशा में और भी अच्छा शोध हो सके, ताकि हरित रसायन के विषय में जो परिचर्चाएं संपूर्ण विश्व में चल रही है उसका लाभ मिलेगा। इसलिए मैं एक बार पुनः आप सबों को बधाई देता हूं कि लगातार कार्यक्रम का तो आयोजन बीच में चल रहा था, इसी बीच में एक अंतर्राष्ट्रीय वेबिनार का भी आयोजन किया गया है। तो कहीं न कहीं दार्शनिक तो हम सभी हैं, क्योंकि दर्शन का संबंध है चिंतन से। इसलिए चाहे किसी भी विषय के आप टीचर हो, विद्यार्थी हो, पहला आप दार्शनिक हैं। इसलिए आपका चिंतन यदि उत्कृष्ट स्तर का होता है तो आप उच्च कोटि के दार्शनिक हैं और आपका चिंतन निम्न कोटि का होता है तो निम्न कोटि के दार्शनिक है। इसलिए आपको यह तय करना है कि आपका चिंतन किस दिशा में हो ताकि हमारा आने वाला भविष्य उज्जवल हो। इसलिए सस्टेनेबल केमिस्ट्री के फ्यूचर के विषय में जब बात हम कर रहे हैं तो निश्चित रूप से हमें यह सोचना होगा कि हमारा कल कैसा हो, हमारे आने वाली पीढ़ी को हम क्या देने जा रहे हैं। इसलिए हम आने वाली पीढ़ी के विषय में जरूर चिंतन करना चाहिए और उस दिशा में कुछ ऐसा प्रयास करना चाहिए कि आने वाली पीढ़ी भी हमारा सुरक्षित रह सके। इन्हीं शब्दों के साथ मैं बहुत समय नहीं लेते हुए आप सबों को बधाई देता हूं और धन्यवाद देता हूं। एक बार पुनः आयोजक मंडल, महाविद्यालय के प्रधानाचार्य, कन्वेनर सुधांशु शेखर जी और आनंद मोहन जी को पुनः बधाई देता हूं। धन्यवाद।
बहुत बहुत धन्यवाद सर। आपने अपना उत्कृष्ट व्याख्यान बहुत ही ज्ञानवर्धक, प्रेरणादायक दिया। इसके लिए विश्वविद्यालय परिवार की ओर से आपको धन्यवाद ज्ञापन करते हैं। आप सभी लोगों के सहयोग से दर्शन परिषद के द्वारा प्रायोजित और टीपी कॉलेज मधेपुरा के आंगन में ये वेबिनार, इंटरनेशनल वेबिनार का आयोजन हुआ। इसके लिए आप सबों लोगों का आशीर्वाद, स्नेह और इसी के साथ जो है आपका धन्यवाद ज्ञापन करते हैं, आपका अभिनंदन करते हैं, आपका वंदन करते हैं, आपको प्रणाम करते हैं। बहुत बहुत धन्यवाद सर। इस कड़ी में आगे बढ़ते हुए हम अपने टीपी कॉलेज मधेपुरा के यशस्वी प्रधानाचार्य प्रोफेसर डॉक्टर केपी यादव सर का बहुत बहुत धन्यवाद ज्ञापन करते हैं, उनको प्रति आभार व्यक्त करते हैं। उनके आशीर्वाद से यह कार्यक्रम का सफल संचालन हुआ। बीएन ओझा सर जो हमारे दर्शन परिषद के अध्यक्ष हैं, उनके सहयोग से उनके द्वारा प्रायोजित यह वेबिनार कम सेमिनार जो इंटरनेशनल है उस सफल उसका आयोजन हुआ। सब लोगों के आशीर्वाद से, सब लोगों के स्नेह से, सब लोगों के सहयोग से यह इंटरनेशनल वेबिनार का आयोजन हुआ। अब हम इस कड़ी में आगे बढ़ते हुए डॉक्टर सुधांशु शेखर सर से अनुरोध करेंगे, आग्रह करेंगे कि वो सभी लोगों का धन्यवाद ज्ञापन करें। डॉक्टर सुधांशु शेखर सर।
जी अनम्यूट कर रहे हैं सर। फिर से भैया का नाम बोलना होगा। धन्यवाद अरुण मोहन जी। आज इस कार्यक्रम में मंच पे हमारे साथ मौजूद बीएन मुस्टा के महासचिव और हमारे विश्वविद्यालय में रसायन शास्त्र के विद्वान प्राध्यापक और शिक्षा शास्त्र संकाय के प्रोफेसर इंचार्ज हमारे बड़े भाई प्रोफेसर नरेश कुमार जी, जिनके आने से यह शिक्षा शास्त्र विभाग पूरी तरह से बदल गया है, परिवर्तित हो गया है और केमिस्ट्री के शब्दों में कहें, आज के सेमिनार के शब्दों में कहें तो सस्टेनेबल डेवलपमेंट की ओर आगे बढ़ रहा है। सबसे पहले मैं अपने बड़े भाई को प्रणाम करता हूं कि उन्होंने हम सबों को यह जगह उपलब्ध करवाया और उनका यह प्रेम है, सहयोग है और उनका यह भाग्य कहिए या उनकी यह यश और कीर्ति कहिए कि जब से वो यहाँ आए हैं और विशेष रूप से जब से यह हॉल बना है या कहिए कि बनने के पहले ही इस हॉल का निर्माण ही हम लोगों ने कार्यक्रम के माध्यम से किया है। बनने के पहले से ही यहाँ से हम लोगों ने कार्यक्रम की शुरुआत की और कई व्याख्यान इस हॉल से आयोजित हुए और लगातार हम राष्ट्रीय सेमिनारों का आयोजन कर रहे हैं। अंतर्राष्ट्रीय सेमिनार भी आज आयोजित हो रहा है। फिर 11 तारीख को हम लोग का सेमिनार है, पुनः 12 तारीख को भी सेमिनार है। तो लगातार कार्यक्रम का आयोजन हो रहा है। इसके लिए हमारे बड़े भाई नरेश कुमार बधाई के भी पात्र हैं और मैं उन्हें प्रणाम करता हूं। हमारे साथ हमारे बड़े भाई और सीएम साइंस कॉलेज में कॉमर्स के व्याख्याता एवं एनएसएस के कार्यक्रम पदाधिकारी भी हैं डॉक्टर संजय परमार जी एवं हमारे एक और बड़े भाई, मैं नाम थोड़ा भूल जाता हूं, इसकी क्षमा प्रार्थना है, सिकंदर बाबू। मैं तीनों को प्रणाम करता हूं एवं कार्यक्रम के आयोजन में लगे हुए मेरे सभी छोटे भाई अरुल मोहन जी जो आज के हमारे इस कार्यक्रम के आयोजन सचिव भी हैं और इस कार्यक्रम के आयोजन में उनकी महती भूमिका रही है और हम सभी सेमिनार को जो सफलतापूर्वक आयोजित कर पा रहे हैं इसमें आनंद मोहन जी का महत्वपूर्ण योगदान है, क्योंकि विश्वविद्यालय की भी हमारे ऊपर कई जिम्मेवारियां हैं, उधर भी हम लोग बिजी हो जाते हैं। इसके बावजूद आनंद मोहन जी, मनीष जी एवं हमारे सभी छोटे भाई इस कार्यक्रम को तत्परता पूर्वक करते हैं और आयोजन का श्रेय हमारे हिस्से जाता है, लेकिन मेहनत हमारे छोटे भाइयों की होती है। इसलिए भी मैं इन तमाम छोटे भाइयों को बधाई देता हूँ, शुभकामनाएं देता हूँ और मेरे हिस्से आज धन्यवाद ज्ञापन की जिम्मेदारी आया है। इस क्रम में मैं सबसे पहले धन्यवाद देना चाहता हूं आज के इस कार्यक्रम के स्वागत वक्तव्य देने वाले दर्शन परिषद बिहार के यशस्वी अध्यक्ष, बीडी कॉलेज पटना के पूर्व प्रधानाचार्य, जिन्होंने कई पुस्तकों की भी रचना की है और जिनके नेतृत्व में बिहार दर्शन परिषद निरंतर प्रगति की ओर अग्रसर है। लगातार परिषद के सम्मेलन आयोजित हो रहे हैं। परिषद के तत्वावधान में कई सेमिनार, संगोष्ठियों का आयोजन किया जा रहा है और एक शोध पत्रिका का भी प्रकाशन किया जा रहा है। यह सब बीएन ओझा सर के प्रेरणादायी नेतृत्व और उनकी कुशलता और उनकी प्रेरणा का भी फल है। और सबसे बड़ी बात यह कि उन्होंने हमें इस कार्यक्रम के आयोजन की अनुमति दी, इसके लिए भी हम बीएन ओझा सर के प्रति आभार व्यक्त करते हैं और आज के कार्यक्रम में महत्वपूर्ण स्वागत भाषण के लिए हम उन्हें धन्यवाद भी देते हैं। आपका मार्गदर्शन एवं आशीर्वाद हमारी ताकत है। मैं प्रोफेसर बीएन ओझा सर के प्रति आभारी हूँ। मैं आभार व्यक्त करता हूँ और धन्यवाद देता हूँ हमारे विश्वविद्यालय के माननीय कुलपति, दर्शन शास्त्र के विद्वान और अपनी सरलता एवं सहजता के लिए जाने जाने वाले प्रोफेसर ज्ञानंजय द्विवेदी सर का, जिन्होंने अत्यंत व्यस्त समय में से भी वो समय निकालकर हमारे साथ हमारे टीपी कॉलेज मधेपुरा में आए और उन्होंने अपना उद्घाटन वक्तव्य दिया। बहुत ही सारगर्भित वक्तव्य और पूरे कार्यक्रम को दिशा देने वाला वो वक्तव्य था। और दर्शन एवं विज्ञान के बीच एक सामंजस्य कैसे स्थापित हो, विज्ञान एवं अध्यात्म के बीच कैसे सामंजस्य स्थापित हो, इसके लिए आपने जो सूत्र दिया है वह सूत्र निश्चित रूप से हम सबों के लिए प्रेरणा का काम करेगा। और यह कार्यक्रम आपका ही है सर, आपके ही नेतृत्व में, आपके ही प्रेरणा से, आपकी ही अनुमति से यह कार्यक्रम आयोजित हुआ है। हम आपके प्रति धन्यवाद ज्ञापित करते हैं, आपके प्रति आभार व्यक्त करते हैं। मैं आभारी हूँ अपने महाविद्यालय के प्रधानाचार्य प्रोफेसर डॉक्टर केपी यादव सर का, जिनका नेतृत्व हमारे लिए प्रेरणादायी है। और जब कभी भी हमने किसी भी कार्यक्रम का प्रस्ताव दिया है वे सहर्ष उसे स्वीकार करते हैं और प्रधानाचार्य के रूप में नहीं बल्कि आयोजन सचिव के रूप में, और सचिव भी नहीं कहिए, एक कार्यकर्ता के रूप में उस कार्यक्रम की सफलता के लिए दिन रात लगे रहते हैं। किस तरह से सारी व्यवस्था होगी यह सब कुछ देखते हैं और मैं समय पर पहुंचता हूं एक अतिथि के रूप में और हमारे प्रधानाचार्य महोदय आयोजक के रूप में, व्यवस्थापक के रूप में ये सारी व्यवस्था करते हैं। इसके लिए हम प्रधानाचार्य महोदय के प्रति हृदय से आभार व्यक्त करते हैं और उन्हें धन्यवाद देते हैं। और उनके ही बिहाफ में आज हम यह धन्यवाद ज्ञापन कर रहे हैं। कुछ कॉलेज की व्यस्तताएं हैं, कुछ छात्रों का दबाव है, सब कुछ काम में लगे हुए हैं, इसलिए उन्होंने मुझे अपने प्रतिनिधि के रूप में आप सबों के प्रति धन्यवाद ज्ञापित करने के लिए हमें यह मौका दिया है। इसके लिए भी हम उनके प्रति आभार व्यक्त करते हैं और आशा रखते हैं कि उनके नेतृत्व में हमारा यह टीपी कॉलेज मधेपुरा आगे बढ़ेगा। और इसकी स्थापना के लिए हमारे महामना कीर्ति नारायण मंडल साहब ने जो सपना देखा है, उनके सपनों को पूरा करने में हम लोग कामयाब हो गए। इसी आशा एवं विश्वास के साथ मैं केपी यादव सर के प्रति आभार व्यक्त करता हूं, उन्हें धन्यवाद देता हूं। मैं धन्यवाद देना चाहता हूं आज के हमारे इस कार्यक्रम के प्रथम वक्ता डॉक्टर काशीनाथ सर के प्रति, जिन्होंने काफी सारगर्भित व्याख्यान दिया और उनके व्याख्यान से हम सभी लाभान्वित हुए। उसी तरह हमारे बीच डॉक्टर प्रकाश सर, डॉक्टर त्रिपाठी सर एवं डॉक्टर मुरुगन सर का भी बहुत ही सारगर्भित व्याख्यान हुआ। खास करके स्वीडन से हमारे बीच मुरुगन सर जुड़े और उनके जुड़ने से ही हमारा यह कार्यक्रम अंतर्राष्ट्रीय रूप ले सका। इसके लिए भी हम आपके आभारी हैं। हमने ईमेल से आपको आमंत्रण दिया और आपने तत्क्षण उसका हमें स्वीकृति दी, इसके लिए हम आपके प्रति आभार व्यक्त करते हैं और आशा रखते हैं कि हमारे बीएन मंडल विश्वविद्यालय को आगे भी आपका सहयोग एवं आपका प्रेम मिलेगा। हम आपके आभारी हैं। हम प्रोफेसर नरेश कुमार सर के प्रति पहले भी आभार व्यक्त कर चुके हैं, हमारे बड़े भाई हैं और इस कार्यक्रम के आयोजन में और पूरी संवाद श्रृंखला जो हम लोग चला रहे हैं उसकी कहीं न कहीं प्रेरणा की एक कड़ी प्रोफेसर नरेश कुमार सर भी हैं और आज के लिए विशेष रूप से बधाई मैं देता हूं, उनके प्रति आभार व्यक्त करता हूं। काफी सारगर्भित कीनोट एड्रेस उन्होंने प्रस्तुत किया और सबसे बड़ी खूबी मैं देख रहा हूं कि जब कभी भी किसी कार्यक्रम में हम नरेश भैया को मुख्य अतिथि या मुख्य वक्ता बनाते हैं वो उस लिखित भाषण भी अपना प्रेजेंट करते हैं और सबसे बड़ी बात यह कि कार्यक्रम के पूर्व ही हमें वह लिखित भाषण उपलब्ध करवाते हैं। यह इनकी विशेषता है और यह विशेषता हम सभी जो हम लोग नए शिक्षक जो नए शोधार्थी आज इस कार्यक्रम से जुड़े हुए हैं इन सबों को इनसे यह सीख लेनी चाहिए, इस विशेषता को सीखनी चाहिए। हम जब कहीं भी कहीं जाएं, किसी भी सेमिनार में, किसी भी वेबिनार में, किसी भी संगोष्ठी में, सम्मेलन में अपना लिखित वक्तव्य वहां प्रस्तुत करें और उसे पहले से किस तरह से उसे प्री प्लान्ड रूप में तैयार करके उसे दें, इसके लिए हम आपके प्रति आभार व्यक्त करते हैं। और मैं अभी आप सभी श्रोताओं को यह भी बताना चाहता हूं कि आप नरेश बाबू के इस वक्तव्य को हमारे वेबसाइट www.bnmusambad.com पर पढ़ भी सकते हैं, उस पर यह पूरा इनका व्याख्यान उपलब्ध है। हम इनके प्रति आभार व्यक्त करते हैं और आज के इस पूरे कार्यक्रम की अध्यक्षता हमारे दर्शन परिषद बिहार के महामंत्री हमारे बड़े भाई डॉक्टर श्यामल किशोर सर ने निभाई, जो टीपीएस कॉलेज में दर्शन शास्त्र विभाग के अध्यक्ष हैं। आज उनके ऊपर बहुत सारी जिम्मेदारी है। टीपीएस कॉलेज का नैक से मूल्यांकन होना है और उनके ऊपर कॉलेज के शिक्षक संघ के सचिव के रूप में भी, कॉलेज में इग्नू के कोऑर्डिनेटर के रूप में, आईक्यूसी के सदस्य के रूप में, विभिन्न रूपों में उनके ऊपर बहुत सारी जिम्मेदारी है और प्रिंसिपल साहब का उन पर अटूट विश्वास है, उन्हें छोड़ना नहीं चाहते हैं। इसके बावजूद वो डायरेक्ट कॉलेज से तुरंत घर आए और हमारे आग्रह को स्वीकार कर आज उन्होंने अध्यक्षीय भाषण दिया। हम आपके प्रति आभारी हैं और आपने हमें इस सेमिनार श्रृंखला की हमने आपको एक रिक्वेस्ट लेटर भेजा और आपने सहर्ष उसे सहमति प्रदान की। हम आपके प्रति आभारी हैं और निरंतर हमारे विश्वविद्यालय को और मुझे व्यक्तिगत रूप से भी आपका स्नेह एवं आशीर्वाद प्राप्त है, आपका मार्गदर्शन प्राप्त है, यह हमारे लिए गौरव की बात है। और आज मैं दर्शन शास्त्र के क्षेत्र में जो कुछ भी कर पाया हूं उसमें आपकी महती भूमिका रही है और दर्शन परिषद बिहार की महती भूमिका रही है। यह हमारी मातृ संस्था है और हम सब जहां भी कुछ कर पा रहे हैं हमारे उस सभी कार्यों में दर्शन परिषद बिहार की महती भूमिका रही है और परिषद को आगे ले जाने में आपका जो योगदान है उसे कभी नहीं भुलाया जा सकता है। जब भी दर्शन परिषद का इतिहास लिखा जाएगा उसमें आपका नाम स्वर्ण अक्षरों में लिखा जाएगा, क्योंकि बीच के दिनों में जब दर्शन परिषद में कुछ गतिरोध आ गई थी, कुछ शिथिलता आ गई थी, ये डेवलपमेंट रुक गया था और वो उस समय आपने इसे एक डेवलपमेंट की नई दिशा दी और दर्शन परिषद को आप सस्टेनेबल डेवलपमेंट की तरफ ले गए और इसमें आपने कई व्याख्यानों को जोड़ा और ये जो दर्शन परिषद के तत्वावधान में अलग अलग संगोष्ठियां भी आयोजित हो, यह सब भी आपकी ही सोच का परिणाम है। आपकी अनुमति से हमने कुछ वर्ष पहले तिलकामांझी भागलपुर विश्वविद्यालय में भी दर्शन परिषद के तत्वावधान में एक राष्ट्रीय संगोष्ठी का आयोजन किया था और विशेष रूप से आपने सस्टेनेबल डेवलपमेंट पर काफी काम भी किया है। आपने कई आलेख भी लिखे हैं गांधी दर्शन को लेकर के भी। हम आपके आभारी हैं कि आपने आज हमें समय दिया और जितने भी हमारे साथ प्रतिभागी जुड़े आप सबों का आभार व्यक्त करते हुए, आप सबों को धन्यवाद व्यक्त करते हुए मैं आज के अध्यक्ष जी की अनुमति से, माननीय कुलपति जी की अनुमति से और अपने बड़े भाई और यहाँ के प्रोफेसर इंचार्ज नरेश सर की अनुमति से आज के कार्यक्रम की समाप्ति की घोषणा करना चाहूंगा और आप सभी प्रतिभागियों से ये मैं बताना चाहता हूं कि आज ही कुछ घंटों बाद हम सब आपके इस कार्यक्रम का सर्टिफिकेट के लिए फीडबैक लिंक भी अपने वेबसाइट www.bnmu-samvad.com पर जारी करेंगे। साथ ही हमारा जो लाइव प्रोग्राम हमारे YouTube पर चल रहा है उसके कमेंट बॉक्स में भी हम अपना आपके सर्टिफिकेट के लिए लिंक जारी करेंगे, व्हाट्सएप पर भी जारी करेंगे, अपने स्टेटस में भी जारी करेंगे, फेसबुक पर भी जारी करेंगे, विभिन्न माध्यमों से हम कोशिश करेंगे कि निश्चित रूप से आपको फीडबैक लिंक मिलेगा। आप इसके लिए बिल्कुल है जिस किसी ने भी 2 मिनट के लिए भी हमारे कार्यक्रम में भाग लिया है उन सबों को सर्टिफिकेट मिले। इसलिए आप लोग धैर्य एवं विश्वास के साथ हमारे साथ जुड़े रहेंगे, हमें सहयोग करेंगे। इसी आशा एवं विश्वास के साथ आप सबों को बहुत बहुत धन्यवाद, आभार। सभी बड़ों को मेरा प्रणाम एवं छोटों को मेरी शुभकामनाएं। बहुत बहुत धन्यवाद।